All right, so good afternoon and welcome. My name is Jane Bemis, and I am the president of the League of Women Voters for the Long Beach area. Thank you for joining us here at the beautiful Aquarium of the Pacific for our 6th Annual Climate Change Symposium. The League of Women Voters is currently celebrating a 100-year birthday. The League of Women Voters of Long Beach was born 95 years ago. Since our inception, we continue to be a respected source of voting and elections-related information for all residents in Long Beach, Signal Hill, and Lakewood by pursuing our mission of defending democracy and empowering voters. As an activist, grassroots organization, League founders believed that maintaining a nonpartisan stance would protect the fledgling organization from becoming mired in the party politics of the day. We are proud to be an organization fully committed to diversity, equity, and inclusion in principle and in practice. We encourage informed and active participation in government and influence public policy through education and advocacy. We take action on selected government policy issues in the public interest at local, state, and national levels. In January 2019, the League of Women Voters U.S. Board approved a position statement on climate change. The League believes that climate change is a serious threat facing our nation and planet. The League believes that an international approach to combating climate change, including through energy conservation, air pollution controls, building resilience, and promotion of renewable resources, is necessary to protect public health and defend the overall integrity of the global ecosystem. The League supports climate goals and policies that are consistent with the best available climate science and that will ensure a stable climate system for future generations. Individuals, communities, and governments must continue to address this issue while considering the ramifications of their decisions at all levels: local, state, regional, national, and global. The results of a survey conducted in November 2018 by the University of Chicago's Energy Policy Institute and the research organization of the Associated Press, NORC Center for Public Affairs Research, found that nearly half of Americans said today's climate science is more convincing than 5 years ago, with extreme weather driving their views. This past year, we experienced many devastating fires in California. 260,000 acres burned. Persistent drought in the Southwest. Record flooding in Europe. Venice had the worst flooding in 50 years. A heat wave in Europe, where nuclear reactors in France and Germany were forced to reduce output or shut down because the water used to cool them was too warm. The same heat wave in Greenland, causing the surface of the island's vast ice sheet to melt at near record levels, and the current ferocious fires in Australia. I look forward to listening and learning over the next couple of hours. It is a great opportunity for all of us. Before we introduce our panelists and speakers, I want to take a moment to thank the event organizers. Ron Salk and Kim Ritter, the League of Women Voter members and event co-chairs. Jerry Schubel, CEO, Aquarium of the Pacific. Linda Brown, lecture coordinator, Aquarium of the Pacific. David Bader, Director of Education, Aquarium of the Pacific. Adina Metz, Administration, Aquarium of the Pacific. And thank you to several members of the League of Women Voters from the Long Beach area: Lisa Andrea, Jan Gallup, Jay Johnson, Sheila LaFridge, Phyllis O'Connor, and Iris Yoko. I also have one process note. Only written questions for the panel in the second hour of the event will be accepted. We will have volunteers in the auditorium to collect the cards. And now I'd like to introduce you to Kim Ritter, co-chair of this Climate Change Symposium.
Thank you, Jane. Along with my co-chair, Ron Salk, welcome and thank you so much for being here today. I have a few brief program and housekeeping notes for you. During the first portion of the program, we have 4 distinguished experts in their respective fields who will give us an update on the latest climate science. Following their presentations, we will take a 10-minute break. Immediately after reconvening, we will recognize the Camara Girls in Action for their contribution to the arts in our community. We're incredibly excited to have them here with us today. In the final hour, Dr. Jerry Schubel will moderate a panel discussion on the social impacts of climate change with an audience Q&A. As Jane mentioned, we are taking only written questions. If you do not get an index card when you checked in, we have volunteers in the theater who can provide you with one. Are volunteers here? Can you raise your hand? Okay, they might still be checking people in, but they'll make themselves known. When you're ready to submit your questions, please raise your hand with the index card and one of our volunteers will collect it for you. Please also be aware that today's event is being recorded and live streamed. Links to the video will be available on the websites of both the Aquarium and the League of Women Voters at LWVLongbeach.org within the next few days. As we introduce the speakers in the interest of saving time and moving things along, we'll just be announcing who they are and their affiliation, but please look at your program to get their full bios because they are an incredibly experienced and exceptional group of speakers. And then finally, please silence your cell phones. I am now pleased to introduce our first speaker, Dr. Jerry Schubel, CEO and President of the Aquarium of the Pacific.
Thank you, Kim. If I can get my slides. There we are. So California and climate change, leader or laggard? So I'm going to try to give you the data that I think will answer that question, and I think I'll give you the punchline up front. I think we're both a leader and a laggard in climate change in California. Climate change is a global problem, and to mitigate it, we have to reduce greenhouse gas emissions on a global scale. What we do in California matters very little. Now, that doesn't mean we shouldn't be a leader. We should. But more than half of all the greenhouse gas emissions come from Asia, as poor countries are lifting themselves out of poverty. That means, to point out what was said earlier, we have to be an international player. We have to regain that international leadership. The atmosphere is a commons, and the ocean is a commons. They belong to everyone and to no one. The atmosphere has a mixing time of less than 1 year. That means that any greenhouse gases emitted in Indonesia or China or India are mixed throughout the atmosphere in less than 1 year. And so we experience all of that. You will recall from COP15, the Paris meeting in 2015, it set a temperature increase of 1.5 degrees Celsius above pre-industrial revolution levels as an aspirational goal, and 2 degrees Celsius as a critical goal, above which there would be very serious, irreversible consequences. How have we done? Not so well. CO2 levels are rising. In 2018, global emissions went up by 2.5%. U.S. emissions went up by 3.4%. And in the U.S., this was the largest increase in 8 years. The results for 2019 aren't in, or at least I haven't seen them, but I expect they will show additional increases over 2018. As someone once said, we continue to fiddle as coal burns. Once in the atmosphere, let me go back a second. Once in the atmosphere, CO2 stays there for a long time. 50% of it stays there for decades, roughly 30% for centuries, and 20% for millennia. That means there's already enough CO2 in the atmosphere that if we could reduce emissions to zero tomorrow, we would still experience a warming Earth, a rising sea, a more ocean-acidic ocean, and we would continue to experience more extreme weather-related events. Our activities globally since the Industrial Revolution have committed our ancestors to living in this kind of a world. It does matter, though, how we in California, we in the United States, and in other countries deal with reducing emissions, because the emissions, while reducing them aren't going to help very much until we get near the end of this century. They do set the boundary of how warm the Earth will get, how high sea level will rise, and how serious these temperature extreme related events will be. And so far, about 30% of all the CO2 that's been added to the atmosphere since the Industrial Revolution has been transferred to the ocean. And you probably have heard 90% of the heat goes into the ocean. So the ocean is getting warmer, it's getting more acidic. We are going to have more hot spells. There will be large numbers of deaths caused by hot spells throughout the world. And we're going to have more fires, more droughts, and more intense hurricanes. Maybe not more hurricanes, but more intense. A higher sea with more intense storms will cause all kinds of damage. And hurricanes, El Niños, king tides, all of these lead to flooding. Inundation by sea level rise is a permanent condition, at least on human timescales, and flooding is a temporary one. But if you superimpose these extreme events on top of a higher sea, they do more damage. We're very fortunate to have with us two outstanding scientists to explore sea level rise and the relationship between climate change and extreme weather-related events. Ron Flick is going to talk about sea level rise, and Mark Jackson is going to describe how climate change drives extreme weather-related events. So, a warmer Earth with a higher stand of sea level is locked in, even if we could reduce greenhouse gas emissions to zero tomorrow, which we obviously can't. Is there anything else that we could do? Could we remove CO2 from the atmosphere and lock it safely away? Or could we reduce the amount of incoming solar radiation to cool the Earth temporarily as we search for more sustainable solutions? And Dr. Holly Buck will address those issues. So I want to give you my personal account of how California is doing. We are both a leader and a laggard. We lead in our transition to renewables. I think there's no question about that. But we have no good strategy to get to 100% clean energy by 2045, which is the state's goal. We can get to 80, maybe we could even get to 90%, but we can't get to 100 with what we have now. Not if we want to have electricity at night when the sun isn't shining. We don't have the storage capacity, and nothing is on the horizon that will accommodate that. I think decommissioning the Diablo Canyon nuclear plant early is a mistake. It's a mistake from getting to our climate goals and getting climate under control. When we had both San Onofre and Diablo Canyon, nuclear power accounted for 20% of all of our electrical energy. We now have only one, and the Diablo Canyon, and that generates about 10%. And it's scheduled to close early in 2024 to 2025. Wind and solar are renewable, but are they green? In some ways they're green, but they both are very low energy density. That means they take up a lot of space to generate a certain amount of electricity. Space is nature, it's habitat. And the loss of habitat is the #1 cause of species extinction. There's a field of solar panels. And there some more solar panels. And windmills. And windmills at sea. Nuclear energy has the highest energy density of any source we have. That means it takes up the least amount of space. It's stable, it's steady, it's reliable, it's clean, and it's safe. We're a laggard in California in embracing nuclear energy. I would give us an A for good intentions, and with renewables, I would give us a C for effective strategies to achieve and maintain base load. You probably know, although it's not widely known, we import energy every night from adjoining states, and it's generated by nuclear and fossil fuels. And we rely upon that to keep the lights on at night. About 40% of California's total energy usage comes from transportation. We have a very underdeveloped public transportation system. We have a car culture, and we're making heroic efforts to make our cars more energy efficient and to move toward electric vehicles. That's good, but electric vehicles have to be charged. And where does that energy come from? And as I say, we import quite a bit of energy. In transportation, I think the jury is out on how we will rank in California. Maybe we're a laggard struggling to be a leader. Agriculture. Agriculture is, we in California have the largest agricultural economy of any state in the United States. It accounts for 70% of our freshwater use, and it contributes a little more than 8% of the state's greenhouse gases. Most of those come from emissions. Half of the total come from emissions from livestock and primarily cows. What we should be doing is transferring some of the production of protein on land to the ocean. It would be a healthier source of food, protein for people. It doesn't use any fresh water except when you're doing processing. It has many environmental and health advantages over growing beef. So I think in agriculture we are a laggard in reducing emissions, and we're particularly a laggard in adapting to changing climate. Many of the crops that we now grow will no longer be able to be grown here in California by the end of this century. Why don't we do something in the ocean? The state of California hasn't issued a permit for a new shellfish farm in state waters in more than 20 years. We have never issued a permit for a finfish farm in state waters in California. And in the most recent strategic plan from the Ocean Protection Council, it said calls for a comprehensive plan for aquaculture in the ocean for seaweed and for shellfish, but it mentions finfish being grown on land and not in the ocean. On balance, on mitigation, that means reducing the driving forces of climate change. I think we are a leader, but not a strong one. On the adaptation side, I think we're a laggard. For too many people in our state, and we pride ourselves on having a strong conservation ethic, somehow adapting to climate change is seen as giving in or giving up. And it's not. It's sound policy, and we need to shift the emphasis, I think, to do more of that. I continue to believe that this state should and could be the nation's laboratory for figuring out how to live in the Anthropocene during a time of climate change. But if you're going to be a laboratory, you have to be willing to do experiments. They need to be carefully designed experiments with off-ramps if things go wrong, but you have to do experiments. It's ironic that we've been doing an uncontrolled experiment since the Industrial Revolution, and we're very averse to doing these controlled experiments. But just think of our state. We have more microclimates than any state in the nation. We have more different environments than any state in the nation. We have great universities, public and private, 3 national laboratories, more than 50% of all the venture capital in the entire country. And we are faced with all of the issues of climate change. Every single one is manifested in this state. Unfortunately, we have a regulatory environment in our state that discourages creativity and innovation in dealing with climate change. We just had the last weekend a 3-day forum in this theater talking about the decommissioning of the 27 oil platforms off the state of California. 23 of those are in federal waters, more than 3 miles offshore. 4 of them are in state waters. And the statement was made by a number of the people that we would use the best science in deciding the fates of these platforms. But it was also pointed out by state leaders, we can't consider all the options because the present regulations limit the option that we can consider to full removal. We had scientists here from the Gulf of Mexico, from the North Sea, from California, and almost everyone, I think all the scientists, thought leaving them in place, at least many of them, would be the single best thing. They're great habitat, they enhance fisheries, they also aggregate fishing, and there are many potential beneficial uses that we could use them for. And I think that would be one, if I were you, I would put on my agenda, let's relax some of these constraints in our state so that we can use the very best science dealing with these environmental issues, because much of it comes from our colleges and universities in this state and from our national laboratories. So here's my report card. Mitigation, electricity, renewables, A. Baseload, F. Maybe it should be a D. Transportation, public transportation, F. We keep saying we're going to do all this stuff for the Olympics. With cars, C+. Adaptation with sea level rise, a D, and agriculture, a C. So my report card is pretty harsh. But the potential is there to be the national and international leader. And as I said, I think the single biggest thing we have to change is to loosen up on some regulations that will stimulate curiosity and innovation and tighten down on some others. I think it is a missed opportunity so far, but it is not too late. And I think it's permitting processes, they strangle innovation. They're done with the best of intentions, but they have very bad consequences. Leo Tolstoy once said, science doesn't tell us how to live. It has nothing to contribute on moral grounds. It is the role of society to decide how we will live. I agree with Tolstoy. I also agree with what the late Nobel laureate Richard Feynman said. Asking a lot of uninformed people does not improve the quality of a technical decision. Finding the right balance between those is critical, and it is not easy. And I close, you can lead a human to knowledge, but you can't make him think. Thank you.
Thank you, Jerry. Our next speaker will be Dr. Ron Flick. He is an oceanographer, research associate with the Scripps Institution of Oceanography. Please join me in welcoming Dr. Flick to the stage.
Yeah, it's always fun to go after Jerry's cheerful lead into this. Reminds me of a joke. You know, the horse walks into a bar, bartender goes, "Why the long face?" So now we know why the long face. The title will become self-evident eventually in my talk. At the bottom left, I want to acknowledge the people I work for. My retirement's been delayed. The biography's wrong about that. I work for the California Department of Parks and Recreation 5 days a week, not today. And I'm stationed at Scripps Institution of Oceanography, where I've learned almost everything I know. But I want to acknowledge the two consulting firms I work closely with, Terra Costa Consulting Group and the Coastal Environments in La Jolla. Walter Crampton from Terra Costa, the principal engineer, is here. We will be back for an encore performance in March to talk much more about the specifics of what we can do to adapt some of the coastal areas to the issues, at least the coastal issues, which Jerry touched upon. How does this work? No, not like that. Somebody help me with this. Which way does it go? Which one? Oh, that's a laser pointer. Okay, there we go. All right, cool. So I'm going to take about a half hour for each of these. I had a half hour, right? Jerry told me I had a half hour. I'm gonna try to get through the yellow ones. Talk a little bit more about climate change, the science of it. I'll talk about mean sea level projections, extreme events, which Mark is also going to spend time speaking about, and then some of the needs and some of the choices and trade-offs. And you'll have to come back in March for the rest of it. Now, as far as old news versus fake news, the science behind atmospheric radiation and trapping by small amounts of trace gas, 300, 400, 500 parts per million of CO2, 0.03%, goes back at least a century and a half to mainly John Tyndall, but others, who was an Irish physicist who worked on the radiative properties by making measurements of gases, including CO2, which was called carbonic acid at the time. Those papers were published at the time of the Civil War. So the recognition that CO2 as a greenhouse gas in the atmosphere would lead to warming, right? Because we have greenhouse gases in the atmosphere, the average temperature of the Earth is about 60 degrees rather than 0 degrees. So the greenhouse gas, greenhouse effect is a good thing. When you have too much greenhouse gas, like 90% of your atmosphere is greenhouse gas, then it's called Venus, right? Where the temperature in the daytime is 700 degrees rather than 60. Svante Arrhenius, a Nobel Prize-winning Swede, worked out the estimate is a little bit high, so he said, well, 2 or 3 times CO2 from the whatever it was in the early 1890s, less than 300 parts per million or so, came to the conclusion that you would have about a 14-degree Fahrenheit increase in temperature of the Earth. That's a little bit high. It's probably closer to 5 or 6 or 8 degrees. Nevertheless, this has been known and appreciated and widely accepted in science community. There's no dispute about the basic science of what we're talking about. A New Zealand newspaper article, brief article in 1912, is very definitive. At the time, there was 7 gigatons of carbon dioxide being produced from in the atmosphere from burning of coal, and it says this is going to become a problem in 2 centuries. Well, a century and a half later, or a century or so later, this is becoming evident now. So, as we get into this, now everybody, including Walter, who's a geologist, partly a geologist, get nervous when I talk about geology, but just bear with me here. So the geological long-term perspective is very, very clear where we are in terms of temperature today and likely, very highly likely in the future, from the increase in carbon dioxide and other greenhouse gases in the atmosphere. If we look at the upper right-hand graph there, you see in 1850, pre-industrial times, the high CO2 content in the atmosphere is about 280, is about less than 300 parts per million, also shown in the lower left. So over the last 150 years or so, we have gone from that level under 300 to, I looked it up yesterday, it was 413, right? You can look it up every day. There's measurements of CO2 every day. And along with that, the temperature, the blue curve is the temperature, and there's been an increase in temperature globally of about 1.5 degrees Celsius. So we're already at 1.5 degrees, certainly a degree, over a degree, since the Industrial Revolution began, as Jerry said. The lower graph comes from ice cores from Antarctica, and that goes back with temperature and CO2 for 800,000 years. And what you see there are those large 100,000-year changes in the CO2 and in temperature and in the comings and goings of the glaciations and the ice ages. So over the last 300 years, CO2 in the atmosphere has never been above 300 parts per per million, about 280. And I want to point out the Eemian, so this is where people get nervous. I start talking about geology. So the Eemian was the last time the Earth was warmer than it is now. 120,000 years ago, the temperature was about 5 degrees higher, and sea level was 20 to 30 feet higher. And this gets back to what Jerry said, that this amount of increase of sea level and temperature and all of the other things that go with global warming are already baked in with the CO2 that exists in the atmosphere already. So the lower left here shows population, which is a very touchy subject, and it's all gone quiet since the 70s. You know, in the 70s, we talked about population of the Earth and what the impact of that was. There's a huge debate now whether these greenhouse gases and resource uses and all of these other things that depend on population are really a question of population, or whether they're a question of use. In other words, how much energy, how much space, how much food, how much water each individual consumes, rather than how many individuals. Which one of those is the most important factor? And that's a raging debate. I'm not expert in that. I'm not going to mention that any more than what I've already said. Probably already said too much on that subject, because it is highly controversial. Okay, so in early 1900, as I said, with Svante Arrhenius's picture there, where we were in, actually it was the newspaper article, at 7 gigatons per year. We are now approaching, if you look at where we are today, we're in the 30 to 40. These are two different data sets, so don't give me a hard time about the discrepancy. There's a little bit of a mismatch here. Anyway, we are at a Yogi Berra fork in the road. So when you come to a fork in the road, you got to take it. Now the question is which one we take. And this will show up in the sea level slides I'm going to show in a few minutes. There's a low emissions and a high emissions pathway. So right now we're on the high emissions business as usual pathway. Jerry hinted at this a little bit in his remarks. What we need to do is be on this low emissions pathway, and we need to get there soon to avoid the worst consequences of future climate change. And you know, I don't like paying more for gas or energy than the next guy, but you know, I'm with Greta on this. You gotta, I want you to panic. I want you to act like the house is on fire, because it is. Now, let's get to the sea level and these so-called guidance documents, and I put that in quotation. This is from the Coastal Commission and the Ocean Protection Council, especially the Coastal Commission and the State Lands Commission that issue permits that you have to go get. And you're supposed to take this guidance, which really means that if you want a permit, you better take this into account. That's the short of it. So those are the reports, or the covers of the reports, that the following couple of slides are based on. So there's been science done, not by CCC but OPC, but they packaged this in very nice ways, and I'm showing the graphs on the upper left, high emissions scenario for sea level, and these go out to these go out to, how do I go back? Damn. Can I go back? How do I go back? Anybody know how to go back? Oh, is that it? Yeah, that's it. Oh, no, not that far back. Okay, cool. There we are. All right, so low emission and high emission. Depending on which fork in the road we take, sea level will be in the range that's shown either on the left or on the right graph. So the red graphs, and again here, this is, let me get the right button, there we go. So the data that's in those reports that I showed actually go out to 2150. And this is the first time that these projections have been published, at least in California, for use and consideration in California, that are beyond 2100, okay? But I want to focus on increases up to 2100, and that's what this graph is down here to make this easier to read. And you'll see that now these graphs look like they're on the same scale, but they're not. See, this is 10 feet and that's 20. So there are two different scales on here. So let's focus on the bottom. So if we end up on high emission scenario, there's a 50-50 chance sea level will be 2.2 feet higher by 2100 than it was in 2000. It's half of that if we end up on a low emission scenario, and so on. Now, the other new thing here, or the most important new thing here, is that the science has now been developed to where there can be ranges of probability, and this is something new over the last few years, ranges of probability for given heights of sea level by 2100. So here, for example, on the high trajectory, you're likely, 2/3 likely to be between 1.2 and 3.2 feet by 2100. In the low scenario, it's lower than that. There's a 1 in 20 or 5% chance that it'll be higher than 4 feet. 1 in 200 or 0.5% chance will be higher than 6.7 feet, and so on, and that's what these graphs show. So this is useful, for considering future development on the coast. And in fact, not just useful, but required. If you want to do anything on the coast, you're required to consider these numbers. So what about some data? So this is data from the NOAA tide gauge out here in LA Harbor. And that tide gauge has been in operation since 1925 or so. And what we see here are annual averages, and this is in NAVD 88, which is a geodetic datum that's used for construction and for maps and for land-based. It's a land-based datum that's commonly used for elevation designations and measurements for construction. So that's why I put that on that scale. Now, you can see the observed variability from year to year measured at Los Angeles is, it's almost 1/2 foot, right? So that's a foot, so it's a little over 1/2 foot. When you have an El Nino, like here in 2015 and 1983 El Ninos, here sea level goes up for a time. And so part of the point of this graph is that it's hard to tell, in fact, it's impossible to tell right now, which of these sea level paths that we're actually on because of the natural background variability in sea level. And it'll be another decade or two at least until we know which path we're on, depending on whether we reduce our greenhouse gases or we don't. But the lag is a few decades here anyway, so a few decades worth of sea level rise are already baked into this pie. No matter what we do, as Jerry pointed out. So here's an expansion of that. See the box here, 1970 to 2050, 1980 to 2050, there we go, is here, and it's the same graph in a little bit more detail to show you this. Now, because of the lag and because of the trajectory we're on with burning fossil fuels, the difference between the median, so this is the 50-50, low 50-50 high, half 50-50 it's higher, 50-50 it's lower for the low and high. See, those scenarios are the same up to about 2050 because of what's already baked in, no matter what path Yogi takes in the fork. Now, this is where my grandmother comes in. She was born in 1898. I don't know, babies are a little bit less than 2 feet, maybe they're 18 inches tall, there she is. If you're wondering what a 5-year-old oceanographer looks like in Lederhosen, there you are. So she was born in 1898, she died in 1984. And what you see here, so this is global sea level rise. These are measurements and these are projections out to 2020 or measurements. By 1900, you see the sea level had gone up to her little baby ankles. By the time she died, and she never wore skirts this short either, that's another thing. Love you, Oma. Miss you very much. By the time she died, sea level was up past her ankles, maybe up to her lower thighs. Now, my granddaughter Josephine was born 3 years ago in 2017. She'll be 3 pretty soon. And you see sea level is already up to her little baby waist by now. She, with given the lifespans of the women, right? She has 2 great-grandmothers still that are in their 90s. She has a very, very high probability of living to 90, in which case she'll touch the 22nd century, right, after 2100. Now, no matter which trajectory, even the lowest ones, it's going to be at least up to her fanny or her hips or over her head for the most extreme scenarios. 10 feet by 2100 is the most extreme scenario in the current science thinking. So this is where that idea comes from. This is not your grandmother's sea level that we're talking about. In 4 generations, the entire picture of global sea level is completely different. I know there's some questions, but I think we're going to hold those. Now, it's extremely important to realize that mean sea level doesn't actually flood anything or do any damage, at least not yet, and at least not for the foreseeable future. Even with 2 or 3 feet of extra sea level, that's not what causes the flooding, the erosion, and the damages. It is when high tides, gosh darn it, it is when high tides, come on. Apologize for my lack of buttons. All right, anyway, it's when high tides coincide with enhanced sea levels from climate things like El Nino, for example, that can elevate sea level temporarily for a few years by a half a foot or so. Thank you, whoever did that. And coinciding with big waves from the Pacific that come at specific angles, right, to get in past the island shadows and cause damages. So this is the hurricane in 2014. This is the peninsula, right, that happened to hit and flood some of the peninsula. This wasn't the only time, but it's a really nice picture of wave overtopping. And this is 1983. This is La Jolla Shores, where they've actually monetized these. They have high tide breakfasts. They put in 2-inch thick plexiglass windows in the marine room down here, and they've actually monetized high tide events with storms and big waves because it's really cool. It breaks over the roof and everything is fortified. The piano doesn't float around the dining room anymore like it did during the winter of 1982-83 when the windows broke out. So there's all kinds of data about this, and we can talk about that. The point is that you have to have these extremely rare coincidences of high tides, enhanced sea levels from other effects, and storm waves at exactly the right time to cause the maximum damage. Now, how does this work out? Mark's going to talk a little bit about this also. If you have a distribution of the probability of occurrence of specific temperatures, let's say this could be sea level, this could be temperature, it could be rainfall, it could be any variable that's distributed with the central value, the average value occurring more often, relatively rare cold events and relatively rare warm events, and so this is for temperature. So if you define this as hot and this as cold and this as average, if you change the mean, if you make it warmer and you change the mean temperature, you shift it to the right, here's what that looks like. So there's the old curve up here, and here's the new one shifted a couple of degrees, say, to the right. Now, because of the shape of this bell curve, what ends up happening is you get, see, there's the same hot temperature that is here, but you get a lot more events. It's a lot more common to have hot events, and then you get some new ones that didn't occur at all or very, very rarely in the previous climate, but they now occur as much, much hot superheated events. This could be wildfires, again, this could be sea level, this could be rainfall, or this could be any variable that's affected by a shift in the mean. So this is how the statistics of how this works out from one of these bell curves, for example. Now, there's even a more perverse way to look at this, and that is if you have, and this is also happening in the real climate, if not only do you have a shift to the right, but you have a broadening of this bell curve. See, then you can actually get many more hot events, but also more cold events, because now you have a broadening, and that's what's going on in some ways when the Arctic air comes down because of stalls in the jet stream. The jet stream is not moving the same way as it has because of warming, but when that gets stuck over Minnesota or over Ohio, bringing cold air, it's still cold in the Arctic, and that can get stalled, and so you can get more often and colder cold events in the winter than you did before the warming. See, and this is what confounds people when they see 8 inches of snow or extreme cold in the Midwest. They go, well, where's the global warming? Well, I got news for you. It's a symptom of global warming, and it was predicted in the models. Okay, now this is how this is going to work out with sea level. I'm almost done. Am I close to my 20 minutes here? Okay. Oh, crap. Okay, so this is how it works out with sea level. This is all of the sea level data, the maximum monthly sea level observations in Los Angeles. So this is the once a month occurrence. So every month it's higher than that. Makes sense, they're all higher. This is the NOAA elevation of the 100-year recurrence level, so 7.6 feet. So in the old climate, it's expected that every 100 years you exceed 7.6 feet. Now, as you raise sea level, you see what happens going out here, and this is the 3 foot by 2100 scenario. We are now here in 2020, so you can expect a 7.6 feet every 10 years, right? By mid-century, you get it every year, and finally, you get it at every high tide. So I'll skip some of this stuff. This is some of my favorite quotes, and it illustrates mitigation, adaptation, and retreat, right? So Jim Hansen, 35 years ago, said that we need a carbon tax and rebate in order to pay the full price of carbon so that we let the market sort out winners and losers. There's a funny story about that I don't have time for. Or you can have Winston Churchill approach where you're going to armor the hell out of everything and never retreat and we're going to fight until we die. Okay. And then you have Woody Allen, right? This is from his cabaret act in the 60s. He must have been as funnier than hell when there were 4 people in the whole world that gave a rat's patootie about sea level, right? I've always had an inordinate fear of sea level. Can you imagine? So that's the retreat scenario. All right, this is what you need. You need some flooding, not just the NOAA, sorry Mark, or the Climate Central or whatever thing where you shift a little button on the, God darn it. You shift a little button and raise sea level. You need actual modeling, never mind. There's been trade-offs. You know, sea level's been going up for 20,000 years. California's an eroding coast, even without climate change. So there have been trade-offs between development and natural habitat, for example, wide beaches, preserving the natural features. Those trade-offs and conflicts have been occurring ever since California was settled, and maybe before. Maybe the natives had those kind of conflicts too, I don't know. But anyway, those conflicts will be sharpened and made more critical and more contentious as climate change and especially sea level rise kick in. So in March, you'll have to come back. And it's still damn cold in Antarctica. Take my word for it. I was down there 5 years ago. But warming is now, it's caused by humans. Large changes are already baked in, but action can avoid some of the worst outcomes. Thank you very much.
All right, next up we have Mark Jackson. Mark is a meteorologist with the National Oceanography, and Atmospheric Administration. Thank you.
All right, thank you, Kim. I think Ron needed some technical timeout, so I don't know if I want to touch this mouse too much here, but I'm glad to be here, privileged to be here, honored to be here always at the Aquarium. It's interesting, if you were to go back and plot the request for climate change talks going back, and I've been at the NOAA office in Oxnard since 2005, and just to start off, in case you didn't know it, NOAA actually stands for the National Organization for the Advancement of Acronyms. I think my talk actually has relatively few number of acronyms, and I try to define them for them. But if you plot the number of requests for climate change talks going back to 2005, there was a pretty big uptick back around right after I got here. My very first talk on climate change was actually here at the Aquarium with a teacher conference. And so what's interesting is that the requests have kind of gone down a little bit lately, and I'm not quite sure why. So it's good to be kind of back in the fold. So anyway, I'm the meteorologist in charge up in Oxnard with the National Weather Service. I'm not a climate scientist, so I am a climate communicator, though. One of the main strategic goals of NOAA is to promote climate education. So I'm here to share information with you, share data with you, and with a focus on extreme weather-related events. Now, Ron, which button was it? Not the one with the slash in it? Okay. Oh, that's great. So let me just start off real quick with some reference material. And one of the most prominent pieces of material that everybody should be familiar with is it's called the IPCC, Intergovernmental Panel on Climate Change. The significance of this is that the most recent report came out in 2014. So these they're called assessment reports. And the first one came out in 1990. AR6 is due for release in 2022. And the table on your lower right, the significance of that is that this, when you look at the lead authors that went into each one of these reports, and there's 4 reports here on this latest one. There's 3 working groups. The one on that blue one there, that's a synthesis report. You look at the countries represented. So I remember one time somebody put it in this context. If you went to a doctor and they gave you a diagnosis and then you walked away and says, okay, well, I better go get another diagnosis. So you go get another one and they tell you the same thing. And then 209 doctors later, okay, they're all telling you the same thing. You would probably go do something about it, right? So that's the significance of this report. You can just Google IPCC and get the whole story. So the other part are national assessments. So the National Climate Assessment, or NCA4, which is what will be abbreviated for the rest of the talk, they're under the auspices of the Global Change Research Act of 1990. So NOAA is a lead agency under these climate assessments. The most recent climate assessment just came out in 2018, 2 volumes. And another important part of this is there's California's 4th Climate Change Assessment, and there's the website for that, and that gets down to the state level. And this was put together by many researchers and scientists throughout the state, universities. There's also a state government that was involved in this as well. As a matter of fact, Dr. Schubel you had part of the California or the LA region. I believe it's the California. So you're one of the contributing. So Dr. Schubel is one of the contributing authors. He did the section on sea level rise. So again, these are very valuable pieces of information. I invite you to check those out on your own time. So let's go over some important definitions, since many times it can be kind of confused too. For instance, like Ron said, I don't understand why, what are we talking about global warming? It's snowing up in Boston, and they had record snow last year, whatever year that was. So just real quickly, weather, that's the actual state of the Earth's surface at a given time. So yesterday, downtown Los Angeles had a high of 73 degrees. It was partly cloudy, sunny, pretty nice days, a little bit of wind. That was weather, okay? So climate is the average state of the Earth's surface over a defined period of time. So yesterday's high downtown LA was 73. The normal high for that date, downtown LA, looking at a period of 30 years, typically is 68. Okay, so we were 5 degrees, but actually a pretty nice day. It's a pretty nice day out there today as well. An anomaly is that departure from normal. So 5 degrees was that departure above normal. Global warming is the rising of those global temperatures. I know it seems painfully obvious, but you have to look at it then compared to a baseline period, and all the graphs that I'll show here have some sort of baseline period. So that's global warming, okay? However, climate change is different, okay? You could say that the warming is a change, but that warming brings about other changes that are happening. So we have melting of the glaciers, intense heat waves, sea level rise, of which Ron just talked about. In many cases, they're longer lasting over longer periods of time. Climate variability is something that's always been there. So a great example of that is El Nino or La Nina. So And in California, there are sometimes great impacts from El Nino and La Nina from season to season. When you look at rainfall totals from season to season, you'll see these rises and dips, and that's natural variability. So that's not climate change, but what climate change can do is enhance the effects of those phenomena. El Nino being a classic example, Ron just mentioned, and Jerry also mentioned, when you have sea level rise, when you have El Nino, you have that pooling of warm water in the eastern Pacific, and then you add storms on top of that, which then add a storm surge, and that's where you get your greater impacts. So an extreme event, again, it seems kind of obvious, but it has to be unusually rare for a given time and a given location, and I'll explain that here in a second. So our warming Earth and extremely likely cause. Now, I use the word extremely likely because that comes out of the IPCC report. And they define what all of these confidence levels mean. Extremely likely means 95 to 100% confidence, okay? So this is a graph here. You have one graph which compares to a baseline anomaly. You can see the warming as it goes back into the late 1800s, and you can see the rapid warming we're experiencing. So this is comparing the 2015 and how much we've warmed on average. 16 of the warmest years on record for the globe occurred in the last 17 years. 1998 was the lone exception. So you can see the warming is not uniform. That's another thing to remember. Okay, you have warm pockets, you have cooler pockets. So when you look at it in this graph, so on the two right graphs, you see the warming, but then there's decadal warming, so those horizontal bars as they go up. So you can see as you go back to 1900 or so, you get some variability over time, kind of slow dips and rides, kind of a boring roller coaster. Well, now we're coming up here since the Industrial Revolution of about in the 1950s, 1960s, and you look at that rapid change in decadal increase in averages of temperatures. And just recently, it was announced the decade of the 2010s was the warmest decade on record. So natural versus human contributions to warming. So you can model, climate scientists can model this, and so what they did here on the left in that kind of yellow shaded figure, that's a temperature plot against, and from different observation systems of temperature going back to 1880. So these are global temperatures, and this is the change as it's going up versus, again, another baseline period. And you can see everything, and they have all forcings inside of this model. They have natural forcings, such as the change in solar radiance, things like that. But they also have anthropogenic warming. And you can see that there's a pretty good correlation between what the model shows, but then those shaded yellow areas and what was observed. Now they can go in there and they take out the anthropogenic warming. So now all they're doing is natural factors, and that's that blue line. So you can see when you take out anthropogenic warming, CO2, human influence, you get a drastically different temperature trace, which is on the right. That's all that's only due to natural forcing is that blue shaded area. So understanding extreme events and the connection to climate change. This is a picture from Montecito. So very methodical person. That's kind of my personality. I try to go from left to right. So let's start with a warmer atmosphere. That's the driver. We know that's happening. And probably 7 of 10 of you in this room, if the surveys from the Center for Climate Change Communication from Yale University, which the most recent one was in November, this past November, probably 7 of 10 of you in here understand that we have warming. So I don't have to convince you of that. What does that mean? The atmosphere can hold more water vapor. You have a warmer ocean, as we've seen. Decrease in Arctic sea ice and extent and thickness, ice melt in the Antarctic and the Greenland, which, by the way, sea level rise is not because of sea ice melting in the Arctic. And I challenge you to put an ice cube in a glass of water and watch it melt, and I guarantee your glass of water won't overflow, okay? So it's the landlocked ice, it's Antarctic, it's Greenland, it's those glaciers. That on top of the fact that we're getting thermal expansion in the ocean as well, it's those factors, okay? Positive shift in the mean surface temperature, which Ron helped explain a little bit. So we have more moisture feeding into our storms. There's more available energy. We get larger dips in the jet stream, and I'm glad Ron brought that up because that's a very important part of this. When you talk about the duration of droughts, talk about the duration of heat waves and cold waves, that is directly related to, based on the science, of less ice extent on the Arctic. So there's still cold air up there, okay, and that's still going to come down. Sea level rise, greater evapotranspiration, okay, and that affects, as we see here, now we can get more intense tropical cyclones. We have more energy in the system, not necessarily more tropical cyclones, but more intense. Higher storm, heavier and longer lasting precipitation events, and you can just see some of the other things as you go down the list. The bottom one down there, greater potential for extreme fire behavior. And we have talked to our partner fire agencies, they have seen fire behavior in our recent fires that they've never seen in their career. And some of these firefighters that we work with have been in their fire agencies for 40 years, and they've never seen this kind of fire behavior. So again, there's always been extreme weather events, all right? But climate change can and has altered the frequency, intensity, duration, timing of certain types of extreme weather events when compared to past time periods. And that's an important part to think of. So how do we know which is it attributable to climate change and which one isn't? And with starting in about 2012, I believe, the American Meteorological Society started to issue publications on explaining extreme events in climate change. And this is an annual publication that comes out. And it's a very important science. So what we do is the climate scientists, look at historical records. So how does the frequency change over time? So you hear on the news especially that this was a 100-year flood, but then 2 weeks later, they say, this is a 100-year flood, and you're going, we just had our 100-year flood, so we're good for another 100 years. Well, no, we're not. All that means is that a 100-year flood means there's a 1% chance of that happening in any 1 year. You can get multiple in that year, okay? But what it does mean in terms of climate change, and that graphic over there is a great graphic. It came from climate.gov, is that when you look at today, there's a 40% chance, an increase, 40% increase in chance of that event versus 1900. So Ron had that great plot of sea level, and when you see that we get this time, that time, but now we're getting it more often, okay? So you've increased the probability of that occurring, and many times what you'll hear now in extreme event science is it's 4 times more likely to occur, okay? So we're kind of changing things pretty quickly. So then what they do is they can model the event with and without anthropogenic warming or human influence, or with the prescribed ocean temperature. So that graphic on the right just shows a temperature plot with and without anthropogenic warming. And then when it comes down to it, the attribution to climate change all depends on quality observation records. So for instance, going way back to 1900, how good are your observation records? The model's ability to simulate the event. When you get a model result like what you see on the right, that's a good thing. And then finally, understanding the physical processes behind that extreme event. So when you put it all together, there's different types of extreme events where you can naturally have greater confidence that it's because of global warming, and some that's not so strong of a connection. The worst case is severe convective storms. We just don't have the science right now to be able to model and project long-term with severe convective storms. You won't see much of a change in the number of tornadoes, for instance. But when you look at extreme heat and extreme cold, there's a very strong connection in there. So some of the observed projected changes that we've seen, and this is just looking at the observed changes in temperature and precipitation. So this is annual temperature and the difference of the average for present day 1986 to 2016 compared to 1901 to 1960. Most of the continental US and Alaska and Hawaii have warmed, and warmed significantly. Now when you look down at annual precipitation, same type of thing where you see the green, that means above. That means an increase in precipitation. One thing I want you to notice is that in the Southwest, we're warming and drying. And that's a pretty significant thing when it comes to how we adapt. This is also now looking at California. So this is the temperature and precipitation anomalies from 1895 to 2019. And again, compared to a baseline, I believe this baseline is a 1970 to 2001 baseline. But you can see there's some dips, and there's a pretty significant rise there right towards the end. This is all of California. No real strong signal within the precipitation, and that seems to be common in terms of the West. But when we go down to the South Coast, which basically covers Santa Barbara down through San Diego, this is the same trace over that same period of time. You see we've got some very wet years. Those are most likely El Nino years. But then what happens is that when you look at since the year 2000, and all of these red bars that are popping up are all below average, some very below average. 2014 was the driest on record for the South Coast. 13 of the last 19 water years, from October to September, that's when we get our rain, is over the wintertime, have been below normal, including the driest on record. 2007, okay? So that's and you also see very big swings in wet years, dry years, wet years, dry years. And I'll bring a connection to that here in a second. Ron showed the same plot, but I think it's really important to understand normal distributions in most cases. Many things we do are very normal, and every once in a while we'll step right outside and go to a real expensive restaurant once in a while. But most of the time we go to the same place every time, so it kind of piles up. But when you shift that mean, in this case the temperature, when you shift it over to the right, now you naturally have a better chance of having those very extreme hot temperatures. So when you look at this plot here, which is looking at the percentage of land area in the U.S. that have maximum temperatures that were way above or way below. So where you see the red, that means you had a lot of very warm temperatures, and you see that change since about 2000. And in some years, very warm. 2014 was the warmest. And then you go down and you look at the same thing with precipitation. Those are all measuring the times that you had extreme one-day precipitation amounts that were way above normal. So you can see we're starting to get warmer, and we're also seeing a greater probability of extreme precipitation events. And that was over the U.S. So this was out of the National Climate Assessment, and what this is showing is the annual number of days over 100 degrees Fahrenheit, and this is observed on the left from 1961 to 1979. And then we have the lower emission scenario, which is in the lower left, and then the higher emission scenario in the lower left and the lower in the upper right. So what we're looking at is where you see it burning up down there on the bottom left, literally, that's where we're seeing a great number of increase in 100-degree days, with a focus really on the southwest U.S. and the southern plains. This comes out of the California, or the regional section from the National Climate Assessment, and this is the projected increase in extreme heat. So these are the number of days per year when temperature exceeds 90 degrees Fahrenheit, okay? This is the change in the number of days, and this is mid-century. So what we're talking about is more hot days, and with fairly good confidence. Then we also have projected changes in precipitation. What you want to see on that upper right is where you see green. That's where you have simulated changes. That's where you have more extreme precipitation falling in the wettest day of the year. The bottom right figure shows the number of consecutive dry days. Okay, so in general, the projections show moistening in the northern latitudes, Canada, but then as you go further south, we have drying, but the confidence is fairly low. There's greater confidence, however, that there is going to be an increase in extreme precipitation events. Wildfires. So we have seen larger wildfires in the West. We've seen an increase in number of fires in the West. And there's many physical reasons behind that. We have a tremendous amount of bug kill within the forests, and what we've also seen is a rapid swing in precipitation years that creates a lot of dead fuels, which is still there. Then we get a wet year, and we get a lot of new grasses and finer fuels, which serve as fire starters. So it's a very dangerous combination. So looking at Australia, I didn't want to give this talk without mentioning Australia. But the situation that's happening in Australia, and they've always had years where they've had numerous wildfires, okay? What we're seeing on the left is the annual maximum temperature anomaly over Australia from 1910 to 2019. And again, versus a baseline level, you see tremendous warming that's occurred within the last 20 years. On the right, that's rainfall anomalies. So wherever you see a blue, that means a wet year. Where you see the red, that's a dry year. What we're seeing in Australia right now is we're seeing rapid swings of wet and dry and wet and dry. It wasn't too long ago that there was tremendous flooding in Australia, if you remember correctly. Now we're seeing very rapid swings in Australia. So they call it a whiplash effect. Sea level rise, storm surge, again, it's been brought up numerous times. It's a very important thing to remember. There's also the incident of nuisance flooding with this kind of, you can't really consider that an extreme event, but nuisance flooding is very important. And we are seeing an increase of that, primarily on the Gulf Coast and the Northeast. So summarizing what it means, there's a lot of information here, but this is out of the California's fourth climate change assessment. And what we're seeing with the temperature is that we are seeing more extreme heat events. And that has tremendous impacts on human health, especially considering your population along the South Coast. Higher storm surge, both in the wintertime with winter storms and also when we have summer storms. You know, Ron showed the slide from Hurricane Marie. That had tremendous coastal erosion because of that high surf. Wildfires, because of the reducing snowpack, that also has water implications. Intense precipitation, 100-year storms become 2 to 4 times more likely. Remember that. Drought, more intense and longer, impacts on ecosystems, bud kill, and then area burned by wildfire. And that's this large swing in wet and dry years that can really create a volatile wildfire environment. So what can you do? I won't take credit for this. This is my last slide here. I won't take credit for this quote. It's been given by several climate scientists, the most recent of which, Catherine Hayhoe from Texas Tech University, that there's a TED Talk out there, no silver bullet, but maybe silver buckshot. So what can we do? Because I finally started realizing I just can't give a climate change talk without gloom and doom, without realizing that you can maybe walk away with something. And there's just some examples. But when it comes to adapting and being, we have a phrase in the National Weather Service, a weather-ready nation. That's part of our strategic plan. And you need to be weather-ready and climate-aware. And one of the most important things that people forget is to talk about it. So educate yourself. Go to those links that I put on there from the IPCC and the National Climate Assessment. Be aware of what's happening. And this site right here, climate.gov, is an excellent site to be able to learn more about it. Thank you.
Our next presenter will be Dr. Holly Buck. Dr. Buck is a postdoctoral fellow at UCLA's Institute of the Environment and Sustainability. Dr. Buck?
So we've heard a lot of helpful, challenging, and terrifying information. And if you're like me, I really like to take a nap on Sunday afternoons. And so I commend you for coming here to be in a fairly dark room and listening to these terrifying things. I think it's really brave and encouraging that people are able to confront the crisis that we're in. I'm going to talk about climate restoration. I was wondering if I could get a show of hands of people who've heard this phrase before. Yeah, so a fair bit, maybe a quarter or a third. How many of you have heard about reversing climate change? Almost, yeah, more than half. So is it even possible to restore the climate or reverse climate change? The short answer is that it's complicated. There are some things that possibly could be reversed, possibly like incidents of heat waves and that kind of thing. Other things like extinction are forever. So I don't mean to use this phrase in a simplistic way, but it's a notion that lots of people are starting to explore right now for a couple of reasons. One is that new technologies are being developed for removing carbon from the atmosphere. So I don't know if you saw this past week, Microsoft had an announcement where they have a target now of being carbon negative by 2030. And by 2050, they want to remove of everything they've emitted since 1975. So they want to actually erase previous emissions. That's kind of a really big step. It's a new way of thinking about the problem. And I think they wouldn't say that unless they were confident it was possible to bring these technologies to maturation. They're a tech company, hopefully they know a thing about that. So the other reason why people have started to talk about climate restoration is that so much carbon dioxide has been emitted that by many calculations, we actually have to remove carbon from the atmosphere to keep warming to safe levels. And so this is a special report by the IPCC that was mentioned. It has a fairly dense sentence that I'm going to talk through. They're saying that all pathways that limit global warming to 1.5 C, that's 2.7 Fahrenheit, with limited or no overshoot, that means without overshooting that target and coming back down again, project the use of carbon dioxide removal from between 100 and 1,000 gigatons over the 21st century. And so current emissions are about 50 gigatons of CO2 equivalent. They're saying that carbon dioxide removal would be used to compensate for residual emissions. That means some amount of emissions continuing into the future. And in most cases, achieve net negative emissions to return global warming to 1.5 following a peak. So I'm going to talk a bit more about that notion. Starting with this idea of the carbon budget. And if you saw me last year, some of this will be familiar, but I'm actually going to update it quite a bit because even in a year, a tremendous amount has changed in this space. The carbon budget, not so much. So imagine that each of these squares is 1 billion tons. This would be the budget for 2 degrees, roughly. So every year that goes past, 40 to 50 gigatons is being spent out. Then by 2029, there's about, over a third of this budget is expended. By 2042, the 2 degrees target would be breached. But this isn't an exact calculation. We don't actually know the one number of the carbon budget. So it could be something that's reached much sooner. But this basic principle is why you've probably heard these things about there being 12 or 10 or, I don't know, maybe 9 at this point, years left to address climate change. It's because of this principle that there's a finite number of emissions before certain amounts are locked in. And so here's another figure speaking to this. There's 3 things that I want to point out about this figure. This is a 2 degrees scenario. The first thing that would have to happen is that emissions need to peak and decline very rapidly right now. We all know that. But the next thing is that near the end of the century, there's this moment where there's net negative greenhouse gas emissions, like the IPCC report was pointing to, where more carbon is being removed than emitted. Still some amount of residual emissions, but the balance of that is net negative. The third thing I want to point out about this figure is that those negative emissions actually start to be generated right now because this is a huge amount of infrastructure and investment and capacity and land use change that needs time to mature. So really, that's things that are in the planning right now. And a lot of places have introduced net zero targets, including California. So this is the executive order talking about net negative emissions thereafter, after 2045, carbon neutrality at 2045. So California is committed to this idea. And so you might have the question of, why are there residual emissions? Why isn't it just zero emissions? Why is it this net zero? It's because there's certain sectors of the economy that are really hard to decarbonize. This is from a paper in Science looking globally at how many of those emissions are considered difficult to eliminate. And those are things like iron and steel, manufacturing, cement, load following electricity. We heard about that earlier today. And also transportation. And so the idea is that the negative emissions balance some amount of continuing emissions from these sectors. Here's a look at California's emissions, just for context, about 430 million tons back in 2016, a large amount of those from transport. And there's a new report coming out next week from Lawrence Livermore Labs about how California could be net negative and what their negative emissions strategy could look like. And they calculated that California could actually generate 125 million tons of negative emissions to balance, so residual emissions there. How does one go about generating negative emissions? That would be a very reasonable question. These are some of the carbon removal methods that were reviewed in a report by the National Academies. So some of these are considered biological, also sometimes called natural climate solutions like afforestation, storing more carbon in soils. Others are industrial or engineered, such as direct air capture and bioenergy with carbon capture and storage. And so let's talk about natural climate solutions first, or biological ones. Who here has seen, for example, this regenerative organic standard? One person. Yeah, this is very new, right? But it's something that's coming out. There's these new products on the market that are focused on regenerative agriculture, so agricultural practices to sequester more carbon. And you can now buy beer and cereal and even hats that are grown with regenerative methods. And so the principle behind that is that the soils hold a lot of carbon. A lot of carbon has been lost from the soils via our industrial agricultural systems over quite some time. And so there would be an opportunity to put a lot of more carbon back from the atmosphere into the soil. There's a number of techniques that help with that, including perennials, no-till, cover cropping. And so a big part of California's strategy is in investing in soils through the Healthy Soils program. This is a figure from California's 2030 Natural and Working Lands Climate Change Implementation Plan, and that basically lays out what California wants to do with natural climate solutions more broadly. So you can take a look at that report and download it. But basically they're thinking about what can be done with soil conservation, afforestation, and blue carbon wetland programs, and they have some calculations about their goals there. Here's another way of looking at all of this. And this graph shows where emissions have come from, so fossil fuels and land use change, and also where they're going. So it was mentioned before that a third or so of carbon dioxide is going into the oceans, the atmosphere, the land sink. So some of this is a question of what can this land sink, can this ocean sink have more, and the atmosphere less. It brings up the question of, is it reasonable to expect nature to take up all of this extra emissions from fossil fuel? It's a very tall ask. And so a lot of people are wondering, can we rely on nature to do the work here? It's really tough because for that to happen, a lot of things would have to go in perfect synergy over a very short time. So here's another set of figures. Now I have to figure out the buttons too. You know about going back? Okay. This is another set of figures from that IPCC's special report on 1.5 degrees that came out in 2018. And so a lot of people are really hopeful about this P1 scenario, which is how to achieve the 1.5 degree target without using engineered carbon removal. And so, you'll notice the very steep curve. The other thing that's not so obvious if you just are looking at a graph is the scale of the land use change in this scenario. So that's assuming that vast amounts of land is converting to forest land and that nuclear and renewables are scaling up at huge levels. So for that to happen, everything has to go exactly to plan. That's a large amount of landowners, farmers that have to be coordinated to change how land is being used. It's a tremendous ask. And another thing about natural climate solutions is that the potentials can be high if you're looking at them just year on year, what could be removed. But things like planting trees and soil carbon, regenerative agriculture, they can't continue removing carbon indefinitely because those carbon sinks will fill up and that will plateau. So for some decades, in theory, with a huge amount of effort, you might see removal rates of 2, 3, 5 gigatons per year, but after a few decades, that will level off. Whereas engineered systems theoretically could continue that year on year. And another thing about natural climate solutions is that they can be vulnerable to reversal. So if a wildfire comes through, then that natural carbon is lost back to the atmosphere. If farmers decide to change their practices, then it could be lost again from the soil. So really thinking about this, what strikes me is that, well, first, obviously the need to just reduce emissions and not rely so much on this, because if you think about the effort involved, suppose you spent $1 trillion over 50 years to plant vast amounts of forests like those projections indicate, change agriculture to convince millions of farmers to store carbon in soils. All of that effort would just buy you another 5 years of emissions at our current rate. And then that capacity to do it all again wouldn't be there. So we need to mitigate right away. But also, I'm going to talk a bit more about these engineered solutions and what they might offer. Bioenergy with carbon capture and storage is what has been included in a lot of the modeling that has gone into these reports because it combines technologies that we're already pretty familiar with, which is bioenergy and carbon capture and storage. So this would be a power plant which combusts biomass, separates out the CO2 to be stored safely underground. The problem with this at the scales in the models is that the land demands for growing the feedstock for the bioenergy are pretty massive. Which brings us to direct air capture. So this is a really, I think, exciting technology because it can capture carbon directly from the air and have it be stored underground. So it could be sited at places where you want to inject carbon and store it. This is technology that exists at a pilot stage. This picture is from a facility in Switzerland where the carbon is captured and actually used for growing vegetables in greenhouses. The captured carbon can also be turned into fuel. But if you wanted this to be a truly negative emissions technology, it would need to be stored underground, simply just disposed of, not used for something else. And the thing about this is right now, these technologies require renewable energy to power them if they're going to be actually net negative. So this goes back to nuclear energy. I think it would be far more feasible to power these processes with nuclear energy because of the demands for land if they were to be powered with renewables. And so the scale of this that's already in the models that's being relied on is really massive because roughly you'd need about 1,000 facilities of the type that we use now for carbon capture and storage. There's about 22 operational facilities for just carbon capture and storage with power plants, et cetera, in the world today. That would need to be scaled up to something like 10,000 power plants. This would be an infrastructure on the scale of the existing fossil fuel industry, but for putting carbon back underground. And some scientists have modeled what maybe a pipeline network might look like. So sometimes people think about this and they are terrified by the idea of building out more pollution cleanup infrastructure. It is pretty daunting on one hand. On the other hand, it's kind of awesome that we could actually do this. So the question then is, who is going to build out this infrastructure? And something that's really important to know is that right now, the first kind of larger scale plants are being planned. For example, there's one slated for West Texas that a company, Carbon Engineering, is doing. And the market for this, because there's not currently climate policy in place to actually price carbon, the first initial market is for something called enhanced oil recovery, which is something that's been done for, over 40 years in the US, and it involves injecting carbon underground to recover more oil. That's because right now with primary oil recovery, it only recovers some of the oil. You can go back to these depleted wells, revisit them, flush more oil out by injecting carbon dioxide. And so there's this increasing idea that you could combine CO2 with enhanced oil recovery for climate goals as well. So there's obviously some issues with that. I just wanted to show you about our existing pipeline infrastructure. Right now, CO2 is mined from places in Colorado, from natural sources underground, and piped to Texas. So oil companies that work on this are thinking, well, it would be cheaper to just capture it from the air than pipe it from natural sources, potentially. So there's a market driver. And this is kind of what the state of the conversation looks like in the absence of public demand and imagination for a way of doing it differently. And so one thing to know is that California is actually playing a pretty interesting role in this right now. One thing you should know is that the federal government now has a tax credit for CO2 with enhanced oil recovery, as well as CCS. So people doing this can receive $35 tax credit for every ton of CO2 with EOR. I feel like I'm getting in the weeds here, but this is pretty interesting, actually. So California has a low carbon fuel standard, and what they have done last year is they changed this. They put in a CCS protocol to credit direct air capture projects. Sorry for the acronym. DAC, direct air capture. Anywhere in the world can generate credits under California's policy. So it's actually California's policy on this that is driving the industry in Texas and in other places, potentially around the world. So California is already playing a big and interesting role in the development of this technology. So then there's this question of if you combine the direct air capture with the EOR, the enhanced oil recovery, would that lead to negative emissions oil? That's a visualization of the plant planned in Texas. And the CEO of this company, testified in a congressional hearing about this and suggested that, this technology should receive funding because it gives you choices. You can continue with the airline industry, you can continue with the coal industry, but doing so in a carbon neutral or even carbon negative way. So that's an interesting proposition, to say the least. And California is already can do quite a bit. This is a paper by colleagues in the UC system about how University of California experts can lead on carbon removal. I recommend to check it out because it talks about all the different initiatives, basically a review of what's already being done and how it can work with federal policy. There's plenty more to say here. And I didn't have time today to talk about blocking the sun, although I wrote a book that covers that and other technologies that you could read. It's called After Geoengineering, or just email me if you want to follow up with questions. This is all really daunting, the scale of the negative emissions that in some sense we might already be relying on. But on the other hand, it's really exciting that we actually could clean up some of this problem. And potentially countries like the US, which have a huge historical responsibility for climate change, I think can and have a moral responsibility to take the lead to do some of that. So the questions I would leave you with, if these technologies that can partially restore the climate, if they exist, don't we have the obligation to try to use them for that purpose? big question. I don't know, it's a very nuanced issue. But is another question, is capturing CO2 from the air to produce more oil the way we want to be doing carbon removal? Because it's not the way we have to be doing it. We could just say we want to have a publicly funded program that captures carbon from the air and just puts it underground without involving, new oil production as part of it, possibly. What might the alternatives be? I would love to discuss them all with you. So it's daunting, but there's a lot of stuff we can do, and California is really an ideal place to be experimenting with policy here. So thank you.
I think let's give all our speakers this morning another round of applause, or this afternoon. Okay, so we are now going to take a 10-minute break so you can all get up and stretch your legs, and let's meet back here promptly at 4:45. Thank you.
Getting ready to start our second panel.
Before we move on to our second panel, we have a very special presentation to make. I'm going to hand things over to Dave Bader, who is the Aquarium's Director of Education.
Thank you, Kim. Thank you very much. We have a special announcement today. We have the League of Women Voters of this region has been very gracious in earning a grant from the Port of Long Beach to award some local students in their artistic expression of an issue around climate change. And the Aquarium has been working very closely with some local environmental and social justice groups, community groups within our city, on a project to help the city of Long Beach become more climate resilient, become the model of a climate resilient city. In order to become climate resilient, we know that one of the things you must do is to be connected to your communities and to have those communities themselves be connected to one another. And the best way to do that is to listen and to learn from our local community members. And we've done just that with a group of amazing young women in an organization called the Kamai Girls in Action. And I'd like to invite them up right now. If you could come up. We have Chelsea Chen, Marina Gong, Wendy Ngao, all who were gracious enough to share their poetry with us about what it means to live here in Long Beach, to experience life here in Long Beach, and to express their voice as part of that community. To be resilient means to have all of these voices shared throughout Long Beach, and most importantly, to learn from our communities, to listen to our communities, so that we're understanding what the community would like to become. To listen to the aspirations of the community and address climate resilience based on that. So it's with great pleasure that I'd like to award these three wonderful young ladies an award of $1,000 that the League of Women Voters was able to get with the support of the Port of Long Beach. Thank you very much. I'll pass it back over to Kim.
So we're going to move on to our next panel, which is going to be a discussion of the social impacts of climate change. And this is a brand new subject that we're introducing to this year's symposium. So I'd like to have our panelists please come to the stage. And again, if you need an index card, just raise your hand. And if you have a question to submit, we have 2 question runners in each aisle, and they'll be happy to collect it for you. So a brief introduction of our panel today. We have Dr. Seiji Steinmetz. He is a professor and chair of economics at CSULB. We also have Dr. Lilyhouse Peters, assistant professor of sustainability science, also at Cal State Long Beach. And then also Michael Bone, is it Bone? Bond, I'm sorry. Senior principal of Studio 111 here in Long Beach. And moderating the discussion will be Dr. Jerry Schubel. Thank you.
Thank you. We want to save time for questions. The pile of questions keeps getting thicker and thicker. So, but I invite each of you to make a brief statement, and then I'm going to ask you an open-ended question. Seiji, we're going to start with you. Want to make an opening statement?
All right. Good. So hi, I'm Seiji Steinmetz. I did not prepare anything formal as an opening statement, but I did want to touch on something that Dr. Schubel mentioned earlier, and that is that 40% roughly of California's greenhouse gas emissions come from the transportation sector. Now, my background is in transportation economics, so I'm going to be like a broken record harping on that. I'm an economist. Some people who are environmentally minded kind of hate economists. So I want to basically, I might say things like pricing or financial incentives, and I don't want you to think I'm like money obsessed. And I want you to be familiar with some of the language that economists use. So can I take a second quickly to talk about what an environmental externality is to economists?
Please.
Okay, so how many of you came into the parking structure today? All right, and were you in a big line? All right. Now you were
We like
me.
those big lines.
Okay, yeah, well, no, that's great. Yeah, demand is good. Demand's a good thing. All right, so if you're like me, you probably were following someone who thought they were going to win the lottery. They're going real slow, looking for that one car that's going to stop, instead of going to the top and parking in one of the 50 open spaces. So the person in front of you who stops an entire column, like the entire garage is frozen by this one person. The question is, what is the cost to them of doing that? They have to wait. It's going to cost them a few minutes, right? But what is the social cost of their behavior? Everyone else has to. Right. So the social cost includes him, right? So he has to wait, and everybody in the garage has to wait. The part that he's not thinking about is the everyone else. In other words, the external cost imposed on everyone else is this social cost, part of the social cost that he doesn't have to pay for. So the question is, what if he had to pay everyone a little bit for slowing them down? Do you think he might change his behavior? Right, so do you see how in that sense his behavior, his action was underpriced, and that there's opportunities for a financial incentive to correct the externality, right? And the same thing goes with the environment. When we get on the road, we don't pay the full social cost in terms of the pollution we create, and therefore there's not enough of an incentive for us to drive less or switch to greener modes of transport. All right, so I'll leave it at that for now. We'll touch on that later.
All right, so we'll go right down the line then. Lily, would you like to make an opening statement?
All right. Since I'm going to speak a little bit about climate justice and bring things, I guess our whole panel will kind of bring things down to the ground, human level, and the social impacts, I just wanted to open by defining climate justice and how that approach kind of shifts our attention in certain ways as we think about the climate science that we've just seen in the last kind of hour and a half of presentation. So if you're unfamiliar with kind of climate justice as a movement or as an approach to how we both mitigate, adapt to, and become resilient to climate change, climate justice really focuses our attention on the racial, social, and economic inequalities that both produce and perpetuate uneven climate risks that we see. And that also influences the ability of certain populations to prepare and recover following climate disturbances, such as extreme heat events, flooding, severe air pollution, which we experience here in Long Beach. And so taking climate justice seriously really requires that leaders ensure that people and communities who are most vulnerable to the impacts of climate change, and in many cases are often the least culpable in terms of their emissions, consumption, lifestyle, do not suffer disproportionately as a result of historical and present injustices, disinvestment, and often erasure. And so really kind of the takeaway is while everyone's impacted by climate change, the severity of impacts are not evenly distributed and felt the same by everyone. And one really interesting case that is in a really recent scientific paper to come out, actually looked at extreme heat and found across a national study of cities, they looked at 108 urban areas US-wide and found that formerly red line neighborhoods, so these are areas that in some cases 80 to almost 100 years ago had race-based housing practices or discriminatory kind of practices where mortgage risk was tied to often the percentage of African American or immigrant populations in these neighborhoods, that these impacts are still extremely relevant today, as they found that red line neighborhoods were hotter than non-red line neighborhoods by an average of 5 degrees, and in some cities and neighborhoods it was up to 12 degrees. And so some of these historical structural practices we see actually today really impact how certain areas and communities impact extreme heat, lack of shade, lack of green space, flooding risk, and these kinds of things. So just drawing kind of attention to that, and I'll come back to think about how Long Beach is responding and how we could also do better as we think about climate justice and adaptation practices.
Thank you. Michael?
Good afternoon. Being an architect, I do have a couple of images, so I will pop up here real quick. And you are all very lucky that I did not know Ron was going to show a picture of himself in lederhosen, because I'm German as well, and I could have came and worn my Opa's lederhosen today, and I would have. So, with that, while they're pulling up the images, I just want to provide a little bit of context of who is chasing carbon neutrality. And you'll see in a slide very shortly, they are companies, cities, countries, and states. And our director of sustainability in our office actually put these two together, and they start to graphically show who is participating. And you can see the red ring is actually companies that are pursuing 100% renewable energy. And I'd like to say that our office, which is LEED Platinum and WELL Gold, will be pursuing those, and will be surviving off of solar panels by the end of this year. And so we will be net zero. There are cities, which you can see, and to Jerry's point, with cities as well as countries, not many in Asia, which is a challenge. And with regards to cities, our mayor, Garcia has requested that we become carbon neutral in 2045. So that is not up there, but that is an additional point. And then the next slide, I will not try to use the clicker if they're paying attention up there.
Maybe we...
Oh, there, I can. I got it. First shot. So the other thing that I wanted to share was that the Luskin Center at UCLA is tracking the progress of cities in Southern California that are developing climate action and adaptation programs. So you can see the lightest green to the darkest green. The lightest green is just getting started. And there are 189 cities in Southern California. Of that, I believe it's 61 that have taken a step into addressing, or 64 cities that have taken a step to either conducted a CHG inventory or adopted a target. Out of those, there's 21 that have adopted a target and conducted an inventory. And then you can see the next green dot is adopted a climate action plan, which there are currently 7 cities. And then the next 2 is in progress of incorporating into the general plan. And I believe that's Irvine, West Hollywood, and Pasadena. And then has incorporated into the general plan is the city of Santa Monica. And I'm proud to say that on December 3rd, the city of Long Beach adopted their general plan. I see a cap right there. So we are, I believe, number 2. So in some aspects, our city as well as Southern California is making progress, though there are still 2/3 of the cities that have not done anything.
Okay, so Jim, coming back to you, what are some of the most powerful economic tools for mitigating and adapting to climate change, and how effective is California in using these tools? And do you have some recommendations for us?
Sure. Okay, so let me begin with how effective is California in using its tools. According to a recent presentation, we get a C-. Is my understanding. No, I'll return to that in a second. But was that on a scale or a curve? I was just curious. Because compared to other states, we're probably doing pretty well. Yeah, right.
I think we're doing very well in terms of having lofty goals. Goals don't mean a thing, though, unless you can achieve those.
All right, well, let me give an example of what I think is an achievement where California might be ahead. I'm compelled by examples like the Dr. Buck brought up about the carbon capture markets. I like these policies where the government sets a goal and tells businesses and the markets how to accomplish them and let them use their creativity to figure it out. One example, I'm especially impressed by the Port of Long Beach and Port of Los Angeles, their green port policy, and going with that, their clean air action plan. One economic policy that's dear to me is this idea of vessel speed reduction. You ever heard of this? It's called the Green Flag Incentive Program at the Port of Long Beach. It has another name at the Port of LA, but the Port of Long Beach is the more important one because they're a sponsor here. So just to give you a short version, if you're driving 70 miles an hour on the freeway, compared to driving 35 miles an hour, you're emitting more than twice the pollutants, right? It's a nonlinear emissions profile. So, and ships, believe it or not, put out a great deal of pollution. A lot of it's dirty particulate matter from burning bunker fuel, but they also put out greenhouse gases. Some estimate up to 5% of worldwide greenhouse gas emissions are from ocean-going vessels and related activities. So one way to cut that is to have the ships slow down when they get close to the port. So there's a program that the Port of Long Beach and Port of LA put in where once the ships get close to Point Ferment, so about 40 nautical miles out, if 90% of the time a vessel operator's ships slow down, then they get a 25% reduction in their parking fees, their dockage fees for the entire year. And what they've done is accomplish something over a 90% compliance rate across all the vessel operators. And combined with a few other policies, ocean-going vessel greenhouse gas emissions since that program have fallen by about 25%. So that's an example of a financial incentive that motivates, lets the market figure out how to reduce.
And they've done a very good job. We still have a long ways to go, though, but not just our ports, but all ports, switching to low sulfur fuel, and there's going to be a big focus on the noise of ships and what that noise does to marine life. Right now there's what's called the Quiet Ocean Experiment. I'd like to see our ports be leaders in that. But let me pick up then. So, Lily, you talked about that climate change takes the biggest toll on the most vulnerable, the elderly, the young, the sick. And how are we doing in Long Beach? Because along the 710, this have the highest cancer rates in the state of California. How are we doing?
So similarly, we still have a long way to go, but and a few more kind of statistics that show how long we have to go is a recent USC study found that in Los Angeles, broadly, African American residents are twice as likely to die from heat or from a heat wave than other residents. And we know that along the 710 in West Long Beach, often known as Asthma Alley, where, those of you who live along the 710, where a California Health report found that 14% of Long Beach residents and 15% of Long Beach children suffer from asthma, which is compared to 8% nationally. And we know across Long Beach that those numbers even are uneven, with populations along communities in West Long Beach being disproportionately affected by the 710 freeway, the goods movement, the Port of Long Beach, the rail yards industry, et cetera. If you know East Yard Communities for Environmental Justice, the activist group, they have the hashtag that they often use, which is "We're just fighting to breathe," which seems like a very kind of basic demand, but is actually tied to much larger structural issues. So here in Long Beach, we have, I think, potential and have shown leadership in following some of the kind of best practices for how to become climate resilient, how to become more climate equitable, and working towards climate justice. And really this is around actively engaging frontline communities. And these frontline communities are, kind of Jerry was saying, the people who are disproportionately affected, most likely to be effective, and are often from disadvantaged communities, historically disadvantaged communities, and may have kind of the least power in terms of socioeconomic and political action. And so really actively engaging these communities in research and planning and implementation, education, and decision making. And here, and Dave Bader's in the audience, the Aquarium has a really interesting model of grass tops, which is kind of, if you've heard of grassroots, but going out and really looking for leaders in frontline communities and building kind of climate resilience around those leaders who are trusted in their community, who then become ones who can disseminate education, information to kind of the surrounding community. So using kind of models like that. So that's where a place I think that we have done some experimentation and shown some leadership. And other areas where I think we see some problems, the LA kind of resiliency plan that came out, Resilient LA, last year, really follows this kind of independent, individual first model of how to, be resilient and recover from disaster, which is often really not feasible for frontline communities and for people who don't have access to resources. We've actually seen after disasters like Hurricane Harvey that the wealthier people in society actually often become richer and the poor become significantly poorer and more disadvantaged. And so these kind of individual first models that tell people they need to be self-sufficient for 9 to 12 days following a disaster or a disturbance is really disproportionately affects people who don't have access to resources, who can't store large amounts of goods, don't have access to transportation, et cetera. And so moving towards kind of more collective models is a place where I think we have a long way to go.
So I think we should applaud the progress we've made, but keep our eye on the ball because climate change is going to make it more difficult to achieve these goals, and particularly in terms of air pollution. And I think in general, we're doing a reasonable job in the ports. They lead in this city of looking at climate change, at sea level rise. But we've also got to look at what climate change is going to do to achieving air quality goals. So, Michael, what are some of the strategies that cities can use to adapt and mitigate climate change, to reduce heat island effect? And how's Long Beach doing in its efforts?
Well, that's a long answer, but I think first of all, cities, you saw in that chart there that 2/3 of them still haven't even developed a climate action plan, and I think they need to develop that to create a baseline to see how they can improve and do better. Long Beach is further along. I think obviously with regards to air quality and the extreme heat, creating cool corridors is important, planting trees and creating canopies to allow particularly older folks and folks that don't have air conditioning to be outside in a cooler environment, lightening the street colors. The city of Los Angeles started looking at that a number of years ago. In terms, and this is somewhere, I'm pretty bully on Long Beach, maybe more than you, but I am a little bit frustrated about the tree canopies in Long Beach. The city of Pasadena has inventoried every tree in their city, in the parkways, in the parks, in the private area, in private residential areas and commercial areas that they don't own, and they know how many trees they have. We still don't have a strong understanding of that.
We have plans to plant 10 or 20,000 trees, but we're also cutting down mature trees to give lots more shade.
Right. I believe in March they'll have about 5,000 of those trees planted, and then by 2022 another 5,000. But over the decades, we've been losing more trees than we've been planting. So this is an area that I think could be a wonderful opportunity. During World War I and World War II, when we were all united to fight an enemy, we had this program called the Victory Gardens, where people would grow their own food so that more food could go to soldiers. And I think now is the time for all communities, be it wealthy or poor, that we consider victory forests, that we really start focusing on planting trees. I've heard a lot of excuses about the lack of water and care, but we've been working with tree people and getting communities together to plant trees. We name the trees. The children that plant trees name them. so that families have ownership of the trees and take care of them afterwards. I really think this is an important area that we should take on a much broader scale.
Yeah, and I do too. And just to make it clear, I'm very bullish on Long Beach in California, but I think part of being bullish is being willing to look at the facts and really make your strategies sound, rooted in science and engineering. We don't have very effective mechanisms to insert the latest science and technology into policy-making processes. And once a policy gets made, none of us wants to admit he or she was wrong. It's hard to reverse that. We've got to improve those mechanisms locally, certainly in the state, and I think nationally too. All right, let's see. Well, cycle back. Seiji, so you want to add to your opening statement some of the most powerful economic tools?
Yeah, sure. So again, getting back to this idea of creating market-based incentives and letting individuals and letting companies be creative. Another program where I think California is definitely a leader is in its carbon abatement strategy through cap and trade. And I know it's controversial, right? What permission to pollute? We don't sell permits to run over babies in cars, right? I mean, the idea though of finding, let the policymakers and let society determine what the cap should be. And by cap, of course, I mean the amount of emissions that are allowable, right? And then let industry find creative ways and cost-effective ways to get there. Just to give you, is everybody familiar with cap and trade? Or maybe I can give you the world's most oversimplified example of why economists tend to like cap and trade in terms of achieving a given target of emissions at the lowest possible cost. Right, so suppose we have two companies, A and B, and I'm making this up as I go along, so for you on YouTube or whatever at home, don't pick out the nuances here, the errors. So company A produces ethanol, okay? Now, they emit 150 units of greenhouse gases a year. Company B produces solar panels, they also emit 150. Now, the target for the two companies has now been dropped to 200 units, right? They each have to cut their emissions by 50 units. Now, there could be a command and control approach, which just says each of you is going to have 150 units, figure it out. Or with the idea of a cap and trade system is let's suppose the ethanol producer, they could switch, they could lower their greenhouse gas emissions by, say, switching from corn to sugarcane, right? It's a more efficient way of producing ethanol. Let's suppose they could drop their emissions down to 50 units. They can then take the other, or let me back up. Each company gets 100 unit credit. This is why people hate economists, right? I'm trying to make it as simple as possible, right? So let's suppose the permit to pollute, they each get 100 units of carbon credits to pollute, right? That's 50 lower than they're doing now. Company A, which is a much lower cost reducer of their carbon footprint, let's say they can get down to 50 by switching their fuel input, right? And then they can sell the other 50 to Company B. Now, suppose Company B is never going to get down to the 100 units they're allowed. And they might have to lay people off, or they might have to go out of business. Well, in this way, Company A has a profit incentive to sell their credits to Company B, and Company B gets to stay in business. And on balance, both companies are abating that target level. We're reaching the target, but at a lower social cost.
Thank you. Anybody up here, are you very optimistic about seeing public transportation get a lot of us out of our cars and into public transportation? You are? When is that going to happen? Not in my lifetime.
I'm sorry, I'm already talking too much. But this is a hobby horse of mine. Look, the premise, when I discuss the idea of the externalities, right, the guy who stops in front of you who's not paying the full social cost of his behavior, that's true for every one of us that drives. When we get on the road, right, we slow other people down and we also pollute, but we're not charged for the pollution costs we create or the amount by which we slow other people down. In other words, our driving is underpriced. And there are plenty of, I could draw you a diagram or show you some math. It's very easy to show that the amount of driving that gives you the highest net benefits to society is created when you charge people that external cost, the cost that's imposed on others. When you make people pay for that, then you can reduce the amount of the driving and congestive and polluting behavior to an efficient level. Where do the people, so in other words, you got to price people off the road. Where do they go when you price them off the road? into public transit. So that's, and I'm not, as a transportation economist, we talk about congestion pricing. You ever heard that term? Well, that applies very much as well to pollution externalities, not just congestion externalities. But the short answer is make it more expensive to drive, and then comments lead your hate.
Provide good alternatives then. So
Yes,
that's part of the equation.
I agree, that's part of the equation. I think another way to look at it is putting jobs and housing closer together.
Yeah.
Right now, Long Beach is a commuter suburb.
Right.
75% of the folks that live in Long Beach work somewhere else. I think it's great that we're building more housing, particularly in downtown, and densifying, but we really need to focus on creating more jobs here so that more folks can live and work in the same city. I think one way to perhaps do that is to start asking people where they work in Southern California and find out if there's groups of folks that work for certain companies or industries, and then target those companies and industries to locate a branch here. I think that could be a powerful way to reduce greenhouse gas emissions, particularly since transportation is such a big part of it.
And clustering housing, moderately priced housing along transportation corridors, light rail, and so on. So I can walk to the train and then go to Los Angeles or wherever I'm going. I think what we're going to do is we're going to open this up to some, unless you want to make a...
Just very briefly, I guess, kind of jumping off of that is also to think about often the strategies for resilience and adaptation that are best in terms of climate justice and equity are looking for solutions that shy away from kind of what's sometimes known as perverse resilience or maladaptive strategies, which may help in one sector but actually be really bad, have kind of negative effects for other sectors, and looking for places where you can get or ideally multiple benefits. And one of these areas is to look for mitigation strategies that also reduce pollution, but also reduce toxic contamination, which are often what frontline communities are dealing with in addition to climate impacts. So looking for these types of solutions that can have as many co-benefits as possible, and really investing or at least experimenting in these as we move forward.
We're going to be here till about midnight to get through all these questions. So these questions are not just for the people up here, so we're going to call on you three. I wonder, maybe let's make this, the three of you come up. We've got, one can sit here. We can do this, and I'll move over here. All right. So let's have nice, crisp answers. So what about air travel? Do we have to give up all air travel? Do we have to give up all air travel like Greta and take a boat and leave months in advance? Who wants to answer that? You can do this, Ron.
Ron's got the least to lose, so.
I'm the wrong guy to ask because I've been flying since I was 3 years old, 4 years old. I'm exaggerating a little bit. And if I never fly again, it'll be fine.
But Holly, you must fly a lot with your book, giving talks all over.
I'm trying to do more virtual talks, but it's amazing how badly the tech works for that most of the time. I think that with air travel, I think that carbon negative oil or directly capturing carbon and turning it into fuel, there'll be a powerful rationale to think about that, if not actually do it. Yep. But I think with air travel, the thing to focus on is the huge amount of people that are flying with private jets. I mean, a lot of the aviation increase is expected to come from there.
So Dr. Flick will have to give up his private jet and fly. All right, I think.
If I had a private jet, I would fly.
What tips or resources would you recommend that might help all of us to share with our climate deniers and leaders, and that might spark an interest and penetrate seemingly closed minds in this topic? So how do we get to the climate deniers? What's the best strategy other than a club? Is that the best strategy?
I'll chime in, and I don't know, as a scientist and somebody who, it's interesting. They talk about, do you believe in climate change? Well, it's not a faith, and I think that what's interesting is that it's taken some time, and I pointed out the survey work that's been done from the Center for Climate Change Communications at Yale University, and 7 of 10 understand, is what they said, understand or think that global warming is happening. They actually broke it down by state, and I think in this room it's probably more like 8 of every 10 of you that think that, so that's good. But the problem is that, okay, we think it's happening, or we see it happening, or we know it's happening. Okay, big deal, because then when they went on to ask another question, and that is it affecting you? And a majority of people think that it's affecting somebody else, so that it's not affecting you. And so as far as the denials, I think it's a lot of it in terms of the, extreme weather has been kind of a sort of a blessing and a curse. I think that the people that have been kind of converted to think that global warming is real, they see these extreme events. Now, it's also kind of a curse because you can't attribute every extreme event to climate change, but it's been a good thing. And the problem is that climate change can happen very slowly, and you might all sit here and think, well, it doesn't really affect me, and I'm still going to continue to drive, and it's going to affect somebody else. There's going to be famine and poverty and everywhere else, but not with me. But other ways to present the data, Ron showed the graphic with the ice core data going back to 800,000 years before 1950, and then comparing the kind of carbon increase that we've seen since then, and it's pretty remarkable. So if you don't really think that that's real data, then I don't know if you'll ever think any piece of data is real, but that's one of the most remarkable things that I like to show, and we actually coordinated this, so I didn't show it again, but only Ron showed it. And I think that we have to come up with those kind of creative ways of presenting data besides just a boring red and blue plot.
Yeah, and I think the research shows that too often as scientists, we just pile on more facts to try to convince people, and that doesn't work. The facts have to be translated into information and incorporated into stories that have relevance to them. Ron, you look like you want to say something.
Yeah, I showed a graphic, not a picture, but a graphic of my granddaughter, and I think this is one way you can influence thinking of folks, especially older folks. Folks like me and Jerry were in our 70s, and he's been around since that last ice age. He's 20,000 years ago. He may be around for the next one, but the point is that look at it like insurance. I mean, let's assume it is true. Let's assume everything we're saying is true, and things will deteriorate rapidly climate-wise toward the end of the century. Do you really want to put your kids and grandkids in that position without trying to do everything you can to mitigate what we can mitigate and change?
Good point. This one is for you, Holly. Is there a consensus on how our global climate budget shifts with each year of delay or insufficient action, or at the very least, an envelope of potentialities? I'm not quite sure what that all means.
Well, yeah, I mean, the basic idea is that with each year, some of the budget is spent. So you have to picture it like a bank account with $1,000 in it. If you're spending 40 or 50 a year, eventually, within a few decades, you're out of money.
So we need to move quickly and rapidly to reduce the emission of greenhouse gases.
Very rapidly, because if you're counting on carbon removal to make up for it later, then every year you delay is more carbon removal you're expected to be able to produce.
Good. This is one for Ron Flick. In coming years, property values in the coastal zone may decline due to climate factors, particularly sea level rise. When do you anticipate this happening? 5 years, 10 years, shorter, longer?
I don't know. I'm not a real estate person. I guess this gets back to the uncertainty that I didn't have a lot of time and focus to explain. A lot of this depends on what people do. That's most of the uncertainty in all of those graphs I showed of future possible sea level rises and their probabilities, all of that uncertainty, is it going to be a foot or 10 feet? Most of that depends on what people are going to do. I mean, what are we going to do about mitigating and decreasing the amount of carbon dioxide in the atmosphere? That's the order one question. There's a second order question, and that's what's the ice going to do? And that science is imperfect. It's evolving. It's not controversial. Don't mix those two up. There is science going on to figure out if you have 2-degree warming, how much and how fast will Greenland and Antarctica continue to melt? And that's a technical question we don't know the answer to, but that's not the biggest part of the uncertainty. The uncertainty is what people are going to do. So Jerry, if you tell me which path we're going to be on, then I can make a better guess about what property values will be in the future, because it hinges essentially on that.
But I think it's not next year or the year after.
No, it's not next year. I mean, not much is going to happen as far as the increase in the catastrophic kinds of coastal events like 1982-83, which many of you here may remember, or 97-98, the next big El Nino after that, or the Hurricane Maria in 2014. Those events are going to continue more or less at the same intensity and the same frequency on average, with more or less the same effects as they've had in the previous century for at least the next couple of decades. So as far as we can tell, I think the best science now in sea level and all of the stuff I tried to show and others have tried to explain suggests that not much is going to change over the next few decades unless there's something highly unexpected happens, especially in Antarctica. Now, I've said this before, and then I go home and I read the newspaper tomorrow morning, and the headline is something unexpected is happening in Antarctica. So it's not impossible, but my thinking is that it's not going to be for 20 or 30, maybe 40 years till.
And that's very important, because all this talk about the need for managed retreat, strategic retreat, that may work in some areas where the population density is low and there you can move a short distance away from the coast. Where do you move if you're going to move from Long Beach? And so I think with the knowledge and the technology that we have, you can buy time in order to figure this out properly. And we don't need to scare people about managed retreat.
The whole managed retreat the strategic retreat, when an army retreats, it implies that there's someplace to go. Right. In many of these low-lying barrier spit situations, like the peninsula and like dozens of others in California, starting in Imperial Beach in the south all the way to Humboldt Bay in the north, those are all examples of barrier spits, right? There are leftover barriers, low-lying sandy barriers of various heights, of widths and lengths that have been developed. Now, was it smart to develop those, 50 years ago? Maybe not, knowing what we know now. We'll have to come back. The property owners who are interested in this will have to come back in March when Walter and I will be here. He is a highly qualified and very well respected coastal engineer who makes a living partly by building seawalls. He is both despised and respected because he's honest about the situation by the Coastal Commission staff and everybody else that has dealt with Walter. And I think we'll be in a better position to answer a lot of these specific questions at that time rather than now.
Okay, I assume we want to not only limit climate change, but reverse it. Some believe a shift to regenerative agriculture has the potential to do so. Holly, what are your thoughts? And where does California stand on doing that? And anybody else can add to that.
I think regenerative agriculture has the potential to make, it's like a wedge. It's one of the silver buckshot, right? And there's good reasons to do it in terms of climate adaptation, in terms of being able to deal with extreme weather events. It's great for that. But it can't deal with all of our emissions.
But it can make a contribution.
It can, yeah.
It should be in the portfolio.
Indeed.
And is agriculture in the state of California moving swiftly in that direction of regenerative agriculture?
Not swiftly enough. And a lot of times it's the smaller growers that are doing more kind of boutique projects. But there's some investment. We can grow it.
Well, we ought to. There are some cases we ought to have some economic incentives to do some of these things. We have the largest agricultural economy. We also have the largest ocean economy, and the three top. The first one is tourism, most of it related with beaches. The second one is shipping and transportation, and the third one is offshore oil recovery, oil and gas recovery. By the end of this century, the offshore oil and gas will be gone. And according to the fourth climate assessment, many of our beaches will be gone, and many of our wetlands will be gone. So tourism, unless we figure out create different kinds of tourism, shipping is the only one that remains strong at the end of the century. Anybody have any thoughts about that?
Jerry, I'll just chime in, and it's interesting to note that I think there are cities out there that are beginning to plan now, and that's an important part, is to plan now. It's that don't wait until water's up to your ankles, but plan now. And I just heard a report on NPR last week. The city of Santa Barbara is now beginning their work on preparing for sea level rise mid-century, into the century. I think San Francisco is doing something similar, but I think it's city leaders that recognize that we need to start planning this right now, because these kind of things take a long time to develop.
I'm going to chime in on the whole tree planting issue as well. My son, when he was in elementary school, he came home and he said, I feel like an egg frying in a pan. And I said, why? And he said, because it's so hot. And I said, well, what are you going to do about it? And 2 days later, he said, well, I want to plant trees. So a year and a half later, we planted 50 trees on his campus. If we took every campus in Long Beach Unified and planted 50 trees, we would have the equivalent of 2 Boston Commons parks in terms of trees. That's just the school district. Then there's parkways, there's individual homes. I think this is something that we don't have to wait for government to come in. I think it's something that we all can participate and do something now.
That's right.
Well, it increases property values, life, animal life. It shades, it cleans the air. There's just so many benefits that are overlooked right now.
So I'm going to ask each of you to respond to this. So hearing all these ideas about climate, what can I do in my everyday life to support a better quality of life? Presently, I ride my bike whenever I can. We compost daily, and I try to minimize using any plastics. We'll start down. Seiji, we're going to go in this direction. One thing, just what can an economist do, Seiji? That's really the question.
You want my honest? It's not a very economic answer. You want my honest answer? What's the simple thing you can do to make a contribution?
What?
Paint your roof white.
Good idea.
I'd like to see more white roofs.
Yep.
And this is anecdotal, but we have a sunroom, and we had to re-roof it, and we painted it white instead of black. And at the surface there was a 50-degree drop.
Yeah.
In the temperature of it. Why don't we have more of that? I'll do more economic stuff later, but paint your roof white.
I think that's a good answer. Lily?
Convince someone else that climate change is real and to be more sustainable. I think a lot of the research has shown that people tend to trusted, other people more than, random scientists, government, etc. So if you have a climate denier in your family, in your group of friends, and you're that trusted person, that can be a really good way to, if you're trying to just convince someone to not buy single-use plastic or to make some small change in their behavior. If that comes from you as a trusted person in their lives, it's more likely to take than just reading in the newspaper or hearing something on TV.
Talking about it with friends has been shown to be an effective mechanism. Michael?
I've been biking 2 days a week to work, and I also try to do a shop by bike. And when I go to businesses throughout the city, I tell them that I am buying, and I came here by bike. That's true too.
Mark?
Well, I guess I'll third the talk about it part, and I think, and I had that in one of my slides. That's one of the most important things, is to know about it and talk about it, and not just stop at the, well, global warming is happening, okay, but read about it. There's a lot of information on the web. I referenced that climate.gov, being informed on what's happening, and I'll go back again, just talk about it. And, you know, it might be uncomfortable to talk about with some relatives, but I think that, and especially in involving the youth, you know, kids come home from schools, you know, the more that it's talked about in schools, they come home and tell their parents about it, and, you know, they say, hey, okay, good idea. I think it's great what we're seeing here up in the front and what's happening there. So talk about it.
Holly, what's your one recommendation?
Vote.
Vote. Good answer. Ron, what's your one?
That's what I was going to say. No, seriously. I mean, it's less productive in California as it would be in Ohio, the same vote. But that's a whole different matter. It's a political matter. So thank you. You too.
Okay, what are some of the economic impacts of climate change that will affect the U.S., California, local governments, and individuals? Our economists up here, what are some of the economic impacts?
Well, I mean, I'd have to predict the future, right? I could tell you what the trade-off between fighting climate change and promoting certain types of industry is really, I think, at the heart of the issue, right? You showed us a nice table showing that the lesser developed countries have a much higher carbon footprint than the rest of the world. So there's a trade-off, right? If we don't address carbon in the future, we're gonna be happier now. It's kind of like the grasshopper and the ant, right? Is that the right parable I'm coming up with?
No.
What's that? Right? We can choose to not build infrastructure to deal with climate change now, and that frees up resources for consumption now, right? And that's what a lot of sort of anti-climate change people are sort of thinking. It's just like, look at what's happening to industry, what's going to happen to jobs if we don't do something about climate change. So the impact of not doing something now actually would be kind of positive from an industry standpoint briefly, and then, but I have 3 children. I don't want to know what that's going to do to them in the future, right? Climate change infrastructure and abatement is expensive. So the impact is it's going to be costly, but if the house is on fire, we got to put the fire out, right?
Don't we have an obligation then in the United States to help some of these other lesser developed nations lift themselves out of poverty? Because we went through this, we used fossil fuels. They were cheap, they were abundant, easy to recover. So don't we have an obligation to join the international community?
Is that for everyone?
Anybody who wants
can I just jump in real and just follow up on that, and then you should definitely answer this as our social justice person. Looking at the lesser developed countries having a larger carbon footprint, another way of looking at that same statistic is that it's a luxury to be able to do something about climate change. We are in a very fortunate position to have the resources to actually even talk about doing something about it. And that's probably the right attitude to have, instead of pointing the finger at the lesser developed people about they're not paying their fair share of the solution.
And another kind of issue, which can be controversial, depending on what side you're on, but is thinking about a lot of issues around patents. So we have a lot of renewable technologies, and they're often under certain patents or export. You know, we can't export them to other places, but I think there's a large desire in many developing countries to adopt renewable technologies. And to even, as we've seen in many countries in the developing world, where they actually kind of jump over one stage. So we saw that with telephones, where a lot of countries, you know, that were developing went kind of straight to cell phone technology and satellite technology rather than laying lines for kind of phones. And in many cases, you know, certain countries might be able, if they could adopt technologies and we could, you know, adapt our patent and other export controls to allow for that process, that could actually maybe kind of leap forward over some of the fossil fuel use and into adoption of renewables. And so thinking about strategies outside of our kind of business as usual around, you know, kind of changes profit motivation potentially. But again, if our house is on fire, maybe we need to rethink some of these, you know, policy types of things.
All right, the next one is Bill McKibben says, quote, join with others to change government policy, close quote. The question is that what groups are represented in this room, and the individual is with the Citizens Climate Lobby. I think that's a very important thing, that we join together and change policies that restrict what we can do. And that's one of the things that always bothers me in our state. We don't sometimes we don't base our policies on what the best science tells us. They're based on emotion, and I think that's a mistake. What would our panel have to say about that? What groups are represented here? Go ahead, just holler it out. Climate Reality Project, okay? Pardon? Citizens Climate Lobby, okay? Okay. So we have a number of groups, and I think if we work together on some of those, 350.org Long Beach, okay. So we have a lot of groups represented here, and I think it would be good if the League of Women Voters were to identify for California several laws that restrict the flexibility in evaluating options to deal with some of these problems.
We also had 2 people from Long Beach's Sustainability Office sign up. I don't know if they were able to make it today. And then also someone from Mara Garcia's innovation team. Was she able to make it? Ms. Vargas? All right, well, so those, in addition to the nonprofit groups, those would be the government offices.
Good. Okay. So what effect does changing a state or country's time by moving forward or backward by 1 hour? What happens by delaying? I'm going to put this in the context. If we delay really tackling the major sources of greenhouse gas emissions in this state and in this nation, what happens in all the different aspects? Holly, you talked about this, and so did a number of others. We really need to move quickly and dramatically to reduce greenhouse gas emissions. And as has been said, there's no silver bullet, there may be silver buckshot. You need to put all of these different strategies into a portfolio that fits the particular state. Anybody want to add to that?
I'll just add one example that's maybe tangential, but we've seen, again, with kind of thinking about policies that either restrict or obstruct some experimentation or innovation, or even be able to learn from certain positive things that we're finding. For example, like the utility structure in the state of California often makes it difficult to develop microgrids, which are not necessarily a silver bullet, but could be part of this kind of larger portfolio. And we've seen, first during Hurricane Sandy, NYU had a microgrid, and they were kind of the one spot that was lit up in Manhattan following or in the kind of aftermath of Sandy, and became a spot where people could, come together and have power and access to electricity. And recently in the fires up in Humboldt County in a more rural area, there was actually a microgrid on a Indian reservation, which was when kind of PG&E turned out all of the power in anticipation of the wildfire risk. It's kind of the one area where people could go with that microgrid, and yet often setting up microgrids is difficult due to structural kinds of business as usual. And many of, I think, these infrastructure and structural policies that we have, maybe aren't going to work as we look forward in this next climate period that we've, developed throughout the last century. And so being able to be more flexible and incorporate some of these types of things, I think, is really important.
This person has a 1969 convertible Volkswagen Bug, and he wants to know, what do you do about classic cars that don't get very good mileage?
Don't drive them all the time.
You can keep it so long as you pay for the environmental externality you generate by driving it.
But now mine's not a classic car, but I drive a 2000 Toyota Camry, and if you look at the amount of energy that it would take to create an electric car, I'm a better driver than Ron Flick, who's got a 2000 and what's your new car? Your sports car? No, I'm kidding him. I'm kidding him. So you can keep your 69 bug and until you can get that in place. All right. I'm skeptic. It says Jerry Schubel is skeptical about energy storage advancement in the next 25 years. Are any of you optimistic? Why or why not?
That's not what you said, though.
What did I say?
You said we were lagging in storage.
That's right. No, we are lagging in storage. I expect that we will come up with some. Yeah, okay, and we are lagging in storage, I think. Well, who would like to add to that?
All I can say is that 25 years is a lifetime in electronics and electricity.
In technology.
Yeah, I mean that problem could be solved in 3 years.
I hope you're right. You know, the number one storage mechanism in the United States is pumped storage. That's where you use energy in the daytime, pump it uphill, and then at night you let it come down and it turns the turbines. And that's what Storm King in New York is a great example. We don't have those in California, places where we can do that. We've tried it with using energy during the day to put trains up in the foothills, but by the time the train gets down to the coast, it hasn't generated enough energy to mount to much. Okay, this one's for Dr. Buck. Clearly, climate mitigation requires the adoption of new techniques, and yet new technological solutions are difficult and slow to be embraced by governments and the enterprise. Painfully slow. Any thoughts on a remedy? How can we accelerate embracing some of those strategies and funding the kinds of research and development that are needed?
That's a great question. I'm a big fan of large public R&D because right now a lot of the things that are more in the frontier space are often funded by philanthropy, if they get funded at all. And I think that there's an opportunity here for public R&D that can go to all the universities in the country, not just a couple elite ones, and really be an economic engine for communities that are often not benefiting from these new technologies.
We need to make more government investments in a lot of this. I find it very discouraging that right now in the federal research budget, almost 50% of the total goes to medical research. Now, for those of us who are aging, having better health is nice, but the basic advances come out of physics and chemistry and engineering, maybe even geology, Ron. And when the 50% is divided among all of those, that is not what this nation needs. Anybody want to disagree?
But actually, I want to add something that might be considered controversial by some, but in terms of speeding up the development of technology, I think we need to do more research on the efficacy of technology forcing policies. Let me give some background. When I was in grad school 5 years ago, does anybody remember California Air Resources Board's zero-emission vehicle mandate that said by the year 2003, so this is back in the 90s, they said by 2003, 10% of all cars sold in California have to be zero-emission vehicles. Right? And first of all, that's managing demand, which is already something that you have to scratch your head about. But looking back, so back then in grad school, I thought, I don't even understand this policy. They're trying to tell people what to buy. But the point was to force people to at least start thinking about how to improve battery technology, how to start putting more R&D money, having private sector money put into, just in case this thing sticks or there's legislation that's going to follow that's even more austere, we'd better start thinking about how to do this. And my guess, again, this is the controversial part, is that it was kind of effective. Right, so now we have a new mandate that's coming down. I'm sorry, you're looking at your watch. We have a new mandate that's coming out that half of all trucks, this is another CARB mandate, that half of all heavy-duty trucks coming out of the ports, I think by coming up soon, I don't have the year in my notes, are going to have to be battery electric trucks. And again, it seems like very ambitious, and I don't know if they even care that the goal is actually reached, but it's more of it's like a warning shot across the bow of industry. You'd better do something or we're going to come up with another policy.
And the Port of Long Beach was a leader in what's called cold ironing. So when a ship got to the dock, they turned the engines off, they plugged in, and that significantly reduced greenhouse gas emissions and particulates. But you still have to ask, how is that electrical energy being generated? It's better than what it was. Can we improve? I think we can. This one, in 2 days, the Long Beach City Council will be asked to approve construction of an $85 million swimming pool complex on the beach in Belmont Shore. It would be built on top of a 7-foot-tall concrete base. They are told that it would be safe from sea level rise until 2100. Is this wise? Is it safe? I ask you, Dr. Flick.
Well, just make it a saltwater pool and you're done. I want to add something to the last, and I'd like to have Seiji's response to this. You talked about the cap and trade. I mentioned carbon fee and rebate, right? Which I'd like you to talk to that. But as far as these electric vehicles go, there was an anecdote I heard from somebody, and it was that Henry Ford did not build gasoline-powered Model A's because John Rockefeller put gas stations on every corner. Right? John Rockefeller put gas stations on every corner because of the internal combustion engine. So my question is, or my comment is it wise to mandate electric when we don't really know if that's the best technology to be using? And now there are going to be electric charging stations on every corner, and you're sort of stuck with electric cars. Maybe that's not the most economical way to go. Maybe there's a better way that's unknown if we would pay all the externalities one way or the other. And I think a lot of economists, you may disagree, think that carbon fee and rebate, it's not a tax, it's a fee on carbon, and it's rebated equally through your tax returns, say $500 a person per year. And so rich people like Jerry would get back his $500, but he'd be paying maybe $2,000 a year in gasoline, and poor people like me might be paying $20 with my go-kart, and I get $500 back. You see what I mean? So that would then drive what the most economical way to get around in your car is, rather than telling you what kind of electric vehicle you should have.
No, I absolutely agree. And of course, as an economist, as a transport economist, I mean, the first line of defense is congestion pricing, right? Or other forms. When I say that, I mean paying for the environmental damage that you do, right? The external part of the environmental damage you do. Certainly, in fact, I could even take it a step further. What I would like to see as technology develops in the future, we each get a carbon allowance, right? And we can go online, and for those of us who are really good about it, we can start trading, we can start selling our carbon permits. Right, so it's like cap and trade, but for individuals, and of course, low-income considerations made, extra rebates and fees, or extra permits for people, right, in certain conditions. The whole point about technology forcing, and that's why I said it was controversial, it's almost tongue-in-cheek. But think about, again, remember I talked about the green flag incentive program, this vessel speed reduction program? That was actually developed under threat. There was an assembly bill, I forgot the number, somebody could probably say it, but there was an assembly bill that was going to give much more dire environmental regulations if the ports didn't do something else on their own, right? So the idea is that not necessarily I think we should commit to battery electric vehicles. The idea is that in this, California, this experimental ground, we can start sort of throwing stuff out there and then retract it later, right? Again, warning shots is what I'm saying.
Right. Excellent point. Whenever you specify a technology to solve a problem, you're freezing the innovation in technology. When we passed the Clean Water Act in 1972, it specified all sewage treatment plants had to go to full secondary treatment. It improved things a lot, but it also froze any technological innovation in this country in the field of wastewater treatment. And there still are two plants in the United States that never went to secondary. Okay. How is carbon captured in the soil with respect to agriculture? How is it stored in the earth? Is that for you, Holly?
Yeah, I mean, there's a few different things. One is plants with longer roots, and there's some efforts in breeding plants that have longer roots that can store more carbon. In terms of farming techniques, no-till, cover cropping, really the most probably important ones.
Anybody else want to add anything to that? Okay. How much damage has been done to our efforts to deal with climate change by the current federal administration? How much worse might we anticipate it getting if this administration lasts 4 more years? How difficult might it be to recover what we've lost? Who's over there doesn't work for government that wants to answer that?
I'll say one thing, which is maybe, again, tangential, but I think in these times when, at the federal level, the policy and the investments are not being made that, most of us probably want to see made, is a time, well, one, to vote, but also to look at our local and community structures and to really build those relationships within your local networks in order to, try to become as resilient as we can against the kinds of climate issues that we see arising. And so I would just push there to think kind of across scales. So even if at the federal level, we're not seeing what we want to see, to really think about how we can invest locally, make policy here locally, and then even just invest throughout our own social networks and in our own neighborhoods to really kind of, build up that resilience while maybe we can't, necessarily affect except through voting the higher levels of government.
Ron, you're almost retired. All right. Okay.
Well, I'm trying to think if I should go out on a limb here.
I think you should.
I think I should. I'm going to question in 3 or 4 or even 8 years how much influence an executive branch can actually have, because most of the drivers are economic and they're happening anyway. I mean, there was a promise about coal, bringing back coal, clean coal, all kinds of coal, dirty coal, clean coal, black coal, gray coal, all kinds of coal. The coal industry's collapsed. It's done nothing. There's been no resurgence in coal in the last 3 years. And going back 8 years before that in the previous administration, the lost opportunities there, and this is a personal view, nothing to do with my employers or my other friends, the lost opportunities there may have been a larger loss than the on purpose negative effects of the present 3 or 4 years. So I'm not sure that these things are actually that much in the control of especially an executive branch. There's the deep state, right? I mean, Mark works for the deep state, right? So I'm serious. I mean, if there's a deep state, I work for the deep state in California. There are millions of public employees, and the inertia in that system, I know from experience. If I want to drag my feet, if the boss is listening to this, I'm not dragging my feet. But if I wanted to, and my colleagues wanted to, we can slow things down to a crawl, and nothing much will change very fast. So. I don't know. I'm skeptical. What do you think, Jerry? You've probably thought about this much more than anybody else. But what do you think?
I would agree with you. I think the worst damage is withdrawing from the international community as a leader, and so that brings us to our last question. China and India are the 800-pound gorillas. Can we achieve our goals if they don't significantly and rapidly reduce their greenhouse gas emissions? Anybody?
Yeah, I mean, this is why I started to look more seriously at carbon capture and carbon removal. Even though at first it wasn't very appealing of a solution to me, is because I realized that those technologies, if shared with other countries and developed in other countries, can really make a difference.
Yeah, I think that's a good point, because as I tried to point out, the atmosphere is a commons, a residence time, a mixing time of less than a year. So if we can figure out how to execute on a large scale some of these carbon removal mechanisms, then I think we could offset that.
One of the more important recommendations from the Intergovernmental Panel on Climate Change, as well as the National Climate Assessment, and it's been kind of going all the way back to their assessment, the AR1 Assessment Report 1, but it's become an even stronger message as you get into the later assessment reports, is that it's not just one piece. If you can't just look at mitigation by its, you can't just mitigate and do just that. You have to mitigate, you have to adapt. And it takes all of these things. So I don't want to, throw in the towel or put the white flag up, but we're to a point when especially when you look at the decadal increase in temperatures, and when the announcement comes out that the 2010s were the hottest decade on record. And I said at work, I'll put money down on it that the 2020s are going to beat the 2010s. Okay, so, and when we look at our, another acronym for you, RCP, Representative Concentration Pathways. So with these climate models, they look at 3 pathways, and Ron showed those. We're on the path of the highest pathway, okay? The highest emission scenario, which when you take that highest emission scenario and you look at 2100, the average temperature around the globe will increase by 9 degrees. So bringing it back down to earth, I was telling my wife earlier on the way down here that, so we live in Camarillo, we might reach 100 degrees, once or twice a year. Down the line, it's going to be, we're 115. And I mean, it's serious. You want to talk about Arizona, Phoenix, 115, the warmest temperature I've ever been in is in Phoenix, 114 degrees, and you can't even breathe. Then now go now and add 9 degrees to that. Now on a yearly basis, they're going to be up to 125, and you look at the impacts from that. But we have to try to adapt at the same time we're mitigating, and to be resilient and to continue to talk about it. So all of those parts have to be done together and equally.
And I think, as has been pointed out by a number of you, these effects, they're baked in. We're committed, and we should do everything we can to mitigate, but we should pay more attention, I think, now to adaptation, and that's where I see us falling short, both in our city and in our state. Anybody want to make a last comment? All right, well, please join me in thanking our distinguished speakers.